At this point in the course, we really have learned a lot about building React Native apps. And at this point in the course, we of course built all these apps, all these demos with React Native, but also with this Expo tool, which we used for creating the project in the first course section and which helped us during development. In this course section, we're going to learn how we could build React Native apps without Expo. For this, we are also first of all going to have a closer look under the hood of Expo to understand how exactly Expo works, what it did for us throughout this course, before we then also learn how we can switch away from Expo and which alternatives we have, and how we can build a vanilla React Native project, if you want to call it like this, which is still a React Native project, giving us a React Native app, but a React Native project that does not use Expo at all. Whilst going through the different alternatives and learning how Expo actually works, we will also learn about advantages and disadvantages of the different approaches, and we're going to see, and you're going to learn, which approach might be best for your future projects. So before we dive into any demos and we dive into different apps built in different ways, let's understand how Expo actually worked. Now, of course, we used Expo init to create Expo projects. We did that in the first course section. And then we used this Expo Go app, which we could install on a real device or which was installed for us on the emulators as well, to preview our app during development. And this indeed is a crucial aspect of using Expo. It makes development that easy because Expo installs this extra app, this extra runtime on a device, on an emulator or a real device. And during development, when you write your code, that code is loaded by Expo into that app and executed there, so to say. Which means that you can instantly preview your code. You don't have to install your code or build your code as an app and then install that app. Instead, you have the Expo Go app installed and you can preview your code just like that. This gives us also the advantage that we can just install this Expo Go app from the Google Play Store or the Apple App Store onto any device of our choice, onto our iPhone, onto any Android device, on a phone of one of our friends, and we can then preview the app there during development without building it, publishing it, or anything like this. And that makes development super easy. Now, what is worth noting, therefore, is that during development, when using this Expo approach as we used it in this course, you don't build real app executables. You don't build standalone apps that would be installed on the emulators or on any phones or devices. Instead, it's really just that source code that is loaded or injected into that Expo Go client app and then executed there. But you can still build and publish standalone apps though. This does not mean that when you build an app, it only runs in the Expo Go app. This is a helper during development. But of course, once you're done building your app, when using the approach we used in this course, you will still be able to build your app and publish your app as a standalone app, so that users of your app won't need the Expo Go app. It's really just a helper during development. And in the next course section, when we dive into publishing apps, you will learn how you can publish apps as we build them in this course as standalone iOS or Android apps that do not depend on the Expo Go app. So Expo gives us this helper, but still allows us to publish standalone apps. And this is really important. You can still build and publish standalone apps which are independent of Expo Go. And this will be done with help of a service, EAS, and which we'll take a closer look in the next course section, which helps us build those standalone apps. Therefore, we really have to differentiate between the environment we have during development, and the app we get for production, so when we're finished. And during development, we can move fast and get instant previews on any device thanks to this Expo Go app. And we simply use this shared runtime, this app, to load our code and reflect changes whenever we make them. And for production, we can still build lean, independent, standalone apps that don't need this Expo Go app. And with help of this build service, which we're going to learn about in the next course section, we can even build those apps for any platform. So we can even build iOS apps if we're on a Windows machine, which would not be possible if we had to build them locally. But again, that is something we will explore in the next course section. Now, Expo is really useful because it helps us during development and it makes development so easy and frictionless. What we used in this course is called the Expo Managed Workflow. That's what we used in this course, and that means that we used the Expo Go app and a project created with Expo, with the Expo init command, where during creation we chose the Managed Workflow template, if you recall that. And the advantage of this is that we don't just have the Expo Go app, but we also have a project with a lot of configuration taken away from us in the positive way, so that we don't have to worry about that. We also get an app that already has a lot of things built in, which made working with certain features, for example, native device features, much easier because we don't have to worry about configuring any third-party packages when we wanted to use them and so on. Sometimes, though, you want less configuration out of the box and you want more control. And for those cases, you could consider using the Expo Bear workflow. And we're going to take a look at how that works and what the difference is later in this course section here. Alternatively, you could also build projects that don't use Expo in any way, so that don't use this company and package in any way, and you could just create and manage projects with just the React Native CLI, which is a command line interface provided by the React Native team itself. Now, let's take a quick look at all these differences. Of course, we're also going to see them in action throughout this section. For the managed workflow, as we saw in this course, an advantage is that it's easy to set up and work with. We have quick and frictionless development. We don't really have to worry that much about configuring things, especially if we add third-party packages that use native device features, like the user's location. That is super easy. We didn't have to do a lot there. And we can, as you will see in the next course section, build cross-platform standalone apps, so we have no restriction regarding that. Now, if we need more control, if we, for example, need to write our own native code in Swift or Objective-C or Android or Kotlin, and we need to mix that with our React Native code, which is possible in React Native apps, then we might consider switching to the Bear workflow. This is still a React Native project created with the help of Expo, using some Expo features, but less of those Expo features. It's still relatively easy to set up and work with, and we still have a convenient development experience, though we often won't use the Expo Go app, for example, because that app does not work if you add your own custom native code that should be mixed with your other code. In addition, you might need to worry a bit more about configuring things. This can also be an advantage that you can configure more with this approach, but you also have to configure more. And that can be an advantage, but also a huge disadvantage. And we're going to see what I mean regarding that throughout this course section. Now, regarding the apps you produce, you still produce cross-platform standalone apps. You can still use this build service provided by the Expo company, at which we'll take a look in the next course section, and you can still build your apps in a pretty convenient way. This does not change, but you have more control, but also more things you have to do. Now, you can also build React Native apps without Expo at all, though. When you use just the React Native CLI, you have a more complex setup that's required. You have to do more things on your own all the time. But once everything is set up, development is still pretty convenient. But when you add third-party packages, when you need to tap into native device features, that often requires more configuration effort and can be more cumbersome. Of course, again, the advantage could be that you have more control, but you should be aware of that. Another potential disadvantage is that when you're using the React Native CLI, you can, of course, look for certain third-party companies and providers that might still offer you cloud builds of your apps so that you can still build for multiple platforms. But unlike with Expo, this feature, this support is not built into your app. There is no easy way of getting this set up. And therefore, indeed, you have to build your apps locally, which means that, for example, on Windows machines, you can't build iOS apps because that is a restriction enforced by Apple. You can't do that. So these are the different approaches we have. We used the managed workflow extensively throughout this course. In the next lectures, we're going to see how we could use the Bear workflow instead, before we then also take a look at using the React Native CLI. Now, to get started with the Bear workflow, it's best if you simply search for Expo Bear workflow, and you should find a getting started page, well, that gets you started with that workflow. Now here you learn how you can create a project that uses this Expo workflow, this Bear workflow now. And there is one note I want to make before you try going through these steps. When we used the managed workflow, as mentioned before, we used the Expo Go app for previewing our application. With the Bear workflow, you can also use this Expo Go app for easy previews, but there are restrictions. When you use Expo Go and you also have an app that uses native device code written by you, the Expo Go app won't support that because it can't load and execute that code. Therefore, often when using this Bear workflow, you will not be able, or you might not be able to use the Expo Go app. And therefore, what you need to do is you need to set up your local machine, your computer, such that iOS or Android apps can be built on your local machine, because they need to be built there, because they will then be built before they are shipped to the emulators for preview. So you have to build an app, standalone apps on your machine first before you can preview them, because you can't use this Expo Go wrapper app. And for this reason, my recommendation is that you go to reactnative.dev, and there I recommend that you do go to environment setup and you set up your development environment for local development without Expo, because you will need the same environment if you use the React Native CLI or the Expo Bear workflow without the Expo Go app. So under setting up the development environment, you want to go to the React Native CLI quick start and then follow the different steps for your operating system and the platform you want to build for. However, here's one important restriction. You can only build iOS apps if you have a macOS system. So on macOS, you can build Android and iOS apps. On Windows and Linux, iOS apps are not supported. You can't build and preview them there. That's one important difference compared to the managed workflow that embraced Expo Go. You can build Android apps on Windows and Linux though, and therefore you can of course still do at least that on your local machine when using the Bear workflow or the React Native CLI. So definitely go through these setup steps which you find here for your operating system so that you are able to use the Bear workflow without the Expo Go app, or later in this section, the React Native CLI, which won't use Expo at all. Now, one important note to make here regarding this setup is that you have to go through a couple of steps here, as you see. You don't need to execute the steps where you create a project with React Native, because we're going to do this later, but you need to install Android Studio and set up certain configuration settings. You need to install Xcode and configure this in a certain way. there are some steps to go through. And that is what I was talking about on this slide. With the managed workflow, the setup was very easy. With the Bear workflow, and later also with React Native CLI, there is a more complex setup you have to go through. Not every time you create a new project, but the first time you start working with the Bear workflow or React Native CLI. Once you have Xcode and Android Studio installed, you don't need to go through all of that again and again for every project, but initially it's a bit more work than with the managed workflow. There you also needed Android Studio and Xcode to start simulators, but technically you don't even need those simulators because with the Expo Go app, you could preview an app on your real phone as well. And even with Android Studio and Xcode installed, if you go through the setup instructions here, you will see that some additional extra steps are required besides just installing Xcode and Android Studio. Nonetheless, once you are done here, you are ready to use the Bear workflow without the Expo Go app, and that is what we will do in the next course lecture. So let's now create a new project with the Bear workflow. For this, we can run expo init, as we did it in the first course section. But now here, we can use any name of our choice, like RN course Bear, whatever you want. And very important, now we want to choose minimal here. So an option from that Bear workflow section that we see here at the bottom. Before we used the managed workflow, now we use this Bear workflow. Now, when we confirm this, a new project will be created for us, and I will open this project with Visual Studio Code as I did it before for the managed workflow once this is done. So here the project creation finished for me, and this is the project opened up in Visual Studio Code. Now, it doesn't look too different maybe, but there actually are some differences. For example, we now have an Android and an iOS folder. And in those folders, we find some native code, so some Java or Kotlin code for Android. And we also, of course, find some native code in the iOS folder. And in addition, we also find some configuration files there. For example, in iOS, if we go into the project folder there, we find an info plist file in there, which is required for configuring various things for iOS apps. Things like permissions need to be registered there with appropriate explanation strings. And that's what I meant. You now have to configure more. Expo is doing less configuration for you. In Android, we have the Android manifest XML file nested in the app folder in some subfolders. And there again, we have to manage a bit more when it comes to permissions. And we also will have to manage more things in there if we would want to publish our app. So again, more configuration required in different files instead of configuration taken care of by Expo. It's also worth noting that we now have an index.js file, which we didn't have before, which essentially is responsible for telling React Native that the app component is our root component. It's not a complex file, but before this file wasn't there because Expo did this under the hood. Now this file exists. And if we have a look at app.json, we note that this file is way leaner than what we had before for the Expo managed apps, because before this app.json file could be used for managing both platforms, iOS and Android, with one file, and Expo would then translate the settings from this one file to the different platforms. Now we instead have to do that management directly in some files in the iOS and Android folders, and there's less shared management here with app.json. So these are all a couple of things to be aware of, a couple of things to note, but what we can still do is we can open up our terminal and then build this app for development for preview. However, as mentioned, whilst you can use the Expo Go app for some Bear workflow projects, some also won't support it, and therefore you might need to build this app locally and then install it on the simulators on your local device. And that is why we did go through that setup here for iOS and Android. Now, once that setup was completed though, building and testing your apps locally is easy. You have two scripts here in package.json, which you can execute to build and test your apps locally. And I'm going to do this here by running npm run Android, and this will now build my app as an Android app and start it on an Android emulator, which I already have up and running here. So we can now execute this, and this will now build the app locally and not just push the code to Expo Go, but instead the app is really built locally with help of Android Studio under the hood. And once it was built, it will be installed on the local emulator. Therefore, of course, we can't easily preview it on a real device. At least we would have to connect that real device to this computer to install the app on it. That would be one thing we could do. Now, this initial build can take quite long. Once it was built, the app that is built for development will still have some internal code to receive updates quicker, so subsequent code changes will be reflected in the running app way quicker. But this initial build process takes some time, and I will therefore be back once this is finished. Now, once the build finished, this app is started up on my connected emulator or on my running emulator, and I can preview it here. Again, if I would want to preview it on a real Android device, I could connect a real Android device to my computer, to my machine, and then not have an emulator up and running and run the same command as I just did, npm run Android, and the app would be built for and installed on my real device. So that was Android. Before I show it on iOS, I want to show you how code changes are reflected. We got some starting app here, and that's good enough for now. And if I now add a couple of exclamation marks here, or I replace this with hello world maybe, if I save this, this is still picked up automatically, and this change is now pushed to this installed app because during development, this installed app has basically an internal process that is connected to our local machine that will receive those changes. So those changes are pushed to that process running in our app so that the app can be updated from inside, so to say. Therefore, once we went through that first initial build process, we can still work on that app relatively frictionless and get nice and quick previews. So that is also what I mentioned on the slides. Once everything was set up, the development experience is pretty convenient. Therefore, just as with the managed workflow, you should keep this process up and running, so this npm run Android process in this case, because as long as this is running, code changes will be picked up and pushed to the Android app. If you also want to preview it on iOS at the same time, you can open a second terminal window with the first one still up and running. And there we can now run npm run iOS, and now the app will be built for iOS and executed on the iOS simulator. This only works if you are on a macOS machine though, because this uses Xcode under the hood, and Xcode is not available for Windows or Linux. This is a restriction enforced by Apple. Eventually, the command for iOS also finished, and now the app is also running on the iOS simulator, again as a standalone app that was built locally and now is able to communicate with our machine during development to receive code changes. So that's how we can get started with the bare workflow, how we can create and edit such a first app. Now let's see how we could add a third-party package that uses a native device feature. Now, in order to see how we can use native device features when using a different workflow than the managed workflow, I again want to use Expo Location. This being a bare workflow project allows us to still use all these Expo packages. So we can still use Expo Location, Expo Image Picker, everything we used before, we can still use it, but we might need to go through some extra setup work. So if we have a look at the location package here, we can see that there are extra instructions if we are installing this in a bare React Native app. So we should also follow these additional instructions then. And therefore we should take a look at those by clicking on that link. And then here we can learn that for managed projects, we don't have to do a lot. We just had to follow the other instructions, which wasn't a lot to do. But now for bare React Native projects, we have to install the package, but also do a couple of other things thereafter. And that's what I meant with more configuration required from your side. So what I'll do here is I will copy this command, and then here I'll quit my iOS and Android processes, and I will then run expo install expo location here. And this will now install this package into our project, but once it was installed, I will go through these extra setup steps. And for iOS, for example, we need to set up these extra settings in the info plist file to show the appropriate permission text when permission is requested by the package. So for that, we can add this permission string here so that we are able to request permission to use the user's location whilst the app is in usage. You could also add other strings to request permission when the app is running in the background, but here we'll go with this string. And then we have to locate this info plist file in iOS and then the project name info plist. And in there, we can add this string anywhere in there, just not nested into some other setting. That should be something you ensure. But then we could add it, for example, here at the end simply. Now here between the string tags, you can enter your text that should be shown to the user when permission is requested. And here I say we need your location, but of course you might want to add a better text that provides a better explanation why the permission is needed. And in addition, we also have to run this command here after installing the package. So I'll also do that. In my project here, in my terminal, I will run npx pod-install and then confirm this with a Y. And this will run an extra command that is required to be executed for iOS. For Android, you don't need to execute that. Now that's the iOS setup. For Android, we also need to add some permission settings to the Android manifest XML file. And here we want to add those permissions and then go to Android app source main Android manifest. And here, where we also have some other permissions, we want to add in those permissions which request location-related permissions. Now with that setup done, we can go back to app.js and use this package. Now regarding the usage, that now is the same as before for the managed workflow. So what I'll do here real quick is I will just add a button using this React Native button to keep things simple here. And there I'll give it a title, get location, and on press we add an event handler, and I'll name this function get user location handler, something like this, and connect this to the button. And then we can use this package which we just installed. So following the official usage instructions, we simply import everything as location from expo location here, for example, like this. And in this function, we can then request the appropriate permissions and then get the user's location. And therefore, to keep things really simple, I will copy most of that code here, paste this in here, and now I just want to console log the location. Whoops, the location here. With that, if we now restart npm run Android, and then thereafter also npm run iOS, if you want to test this for both platforms, this will be rebuilt and the updated app will be shipped to the native devices. And you should run npm run Android and iOS again whenever you add such a package, because we tweaked some configuration files for Android and iOS. Therefore, the app should be rebuilt. Just shipping updated code to the already running app won't do the trick. So that's why we have to stop this process and restart it. And then I get an unexpected reserved word await here. Yes, because I'm using await here. This should therefore be an async function. That is true. If we save this and press R, the code is updated. Now the updated code is shipped. This works because I now only changed the code. I didn't change any configuration. And we can press this button. We get prompted to provide permission, and then the location should be fetched. Now, just as before, for me, unfortunately, on the Android device, on the Android emulator, this does not work. Therefore, I also want to show this on iOS by running npm run iOS as well. Of course, you could test it on a real Android device where this should work absolutely fine. But here I'm rebuilding the iOS app now, and thereafter this will also be shipped. This updated app will also be shipped to the simulator. And there, if I press get location, I have to grant this permission. And then here in the terminal where this process is running and watching my code, I see my output here. As a side note, once you started both iOS and Android, once you ran npm run Android and npm run iOS, you can close one of the two terminal windows. Just the one which has still a running process needs to keep up and running. But then this window, this terminal here, actually watches both apps running on both Android and iOS. So that's just a side note. And therefore here we now see this output and we see how we can add and use this package on both Android and iOS apps. And it's definitely not super difficult, but it required a bit more setup work than we needed to do before when we used the managed workflow. In the last lecture, we worked on a Bear workflow project, which we created with Expo init. However, sometimes you might also work on a managed workflow project, and at some point you decide that you want to switch to the Bear workflow because you need more configurability, you want to add native code for such reasons. And the great thing about Expo is that you can eject from the managed workflow to the Bear workflow anytime you want. And that's exactly what we'll do here. Here I have this expense app, which we built as part of the course, not the finished version with HTTP and so on, but the first version which had some basic screens and where we could navigate around and so on. Now let's say that for some reason we want to switch to the Bear workflow. Doing so is super simple. All we have to do here is open our terminal, and then in this project, which again is a managed workflow project, we can run expo eject. And what this will do is it will ask us if we really want to continue. If you're using Git, you can save a commit before you do that so that you can go back, because otherwise there is no going back. Git is your only option to go back to the managed workflow thereafter. But if you are sure, you can continue here, and you can then choose a name for your Android package. This should be an identifier which has a shape like this, basically a reverse URL. And this should be a unique identifier, which is why you typically use something like your company name, maybe your company domain, and then a project name at the end. So here I will choose com.academind.rn course because my company is named Academind. So this is an identifier which will later be important once we publish apps to the app stores. We will talk about this again in the next course section therefore, but here I'll confirm it. And then we can do the same for iOS, and it already suggests that we take the Android identifier here, so we'll hit enter to confirm this. And then it basically ejects this project, which means that it generates the Android and iOS folders, which we already know from before, and that it now does a couple of other adjustments as well. Once it is done, we will indeed have a project that is exactly the same as if we would have created it with the Bear workflow right from the start. And therefore now we have a project where we can run npm run iOS and Android to build those apps locally on our machine, as we did it before in the previous lectures, which we can then run on the emulators or real devices by installing these apps on them. So exactly as I showed it to you in the previous lectures. And therefore here, if I do that, if I run npm run Android here, this will build this app for Android, and the first build will always take a bit longer, and then thereafter it will ship that built app to the running emulator so that we can view it there. And then it will still work as before, but it's now not running in the Expo Go app, but as a standalone app which is built on our machine. And we are then in that Bear workflow with all the advantages and disadvantages. So let's wait for this Android build to finish here. So here we go, the Android build finished, and now this app is starting up on Android as an app installed on that device. And it works just as before. It's the same app as before, but now not running in Expo Go, but as a standalone app that was installed on this device. And of course, we can do the same for iOS. Open a new terminal window, run npm run iOS in there, and now again, this is built locally with help of Xcode and then installed on the iOS simulator so that we can then preview it there and continue working on the app if we want to. So here we go, the app is starting up, and now here's the app running on iOS, just like this. So that is how we can eject from the managed workflow to the bare workflow. And of course, if you want to learn more about that bare workflow, if you want to dive deeper, the official docs are your friends. You can learn more about the different workflows there, about their differences and similarities. You can find more help on which workflow to choose, and you can then also dive deeper into the bare workflow here. If you want to use a third-party package provided by Expo, something like location, which I showed you, but also something like the camera, you always want to have a look at those API reference pages for that package to learn which extra setup might be required. You will basically always find little instructions like this, which lead you to extra pages with more setup instructions that need to be followed when using the bare workflow. So that's always something you have to do. And as you see here for this camera package, for example, sometimes you also don't just need to add some permission settings, but you also might need to tweak some native code, which is found in one of those Android or iOS specific files. So that is the bare workflow and what you can do with that. But sometimes, of course, you don't want to use Expo at all, and therefore in the next lectures we will explore how we can build React Native apps without Expo. So let's now explore how we can create React Native apps without Expo at all. For this, on reactnative.dev, you definitely need to go through that environment setup guide first. And here, of course, the guide for the React Native CLI, because we won't use Expo. I mentioned this guide before, so I won't take a closer look at it here, and I will assume that you did go through that guide. What is important here is that you now also need to go through the steps here at the bottom, though that is the part which we'll do together. Because this is the command which we execute to now create a new React Native project without Expo. Before, we always executed Expo in it. Now, since we don't plan on using Expo, we don't do that. Instead, we should execute npx React Native init and then our project name. So that's what I'll do here. npx React Native init, separated by dashes. And then the project name could be rn no Expo, whatever you want. It should be one word, no dashes, no underscores, just one word like this. And then if you hit enter, this project will be created, at least once this is confirmed. Now this command will now go through the different steps that need to be executed to set up a React Native project without Expo. And in case this command should not work for you, this npx command, you can also alternatively install the React Native CLI globally with npm install-g react-native-cli. On macOS and Linux, you might need to add sudo in front of that. And once it was installed, you can also run react-native init without a dash between native and init, and then your project to create the project. The npx command is preferable, but if that fails, you can use this alternative approach. Once you did that, you can open up the created project with VS Code again, for example. And in there, you will find the React Native project installed here or set up through this React Native CLI. And in that project, you will find a slightly different structure than what you had before. You will still find an app.js file, which comes with a default component set up. But you will also find an index.js file that registers this app component, a bit like the Expo bare workflow did it, though the code is slightly different. And you have a bunch of other configuration files here as well. You also have an app.json file with even less options to set up here though. Again, if you would want to configure your apps, your Android and iOS apps, that would have to be done through the Android and iOS folders and the respective configuration files there. So you need to know what you're doing if you want to configure the app through that. Now, we can still, of course, run this app though. And for this, first of all, I will change this app.js file a little bit. There's way too much in here. I will also get rid of this part here, which is basically some extra type annotation set up by React Native here, or by the React team in their default setup. I will get rid of all that code here, get rid of this code, get rid of this code here, and also clean up this part here so that this is all way leaner, because we don't need all of that here. And then I will just return a basic view with a text where I say hello world. And for this, we need to import view and text from React Native as we did it before in this course. And then here I will add a screen style object where I set flex to 1 and I set align items to center and justify content to center. Like this. That is, by the way, important. As you saw before for the Expo Bear workflow app, and as you see it here again, the code you write in your component files is the same as before. You use the same components, you style your app in the same way. It's not different here. The main difference really is the configuration that you might need to add, and when you add third-party packages, especially packages that tap into native device features, then you might need to do more work. That's the difference. The code you write is the same as you saw before. So here I will then link this screen style object to this view. And then, just as before in the Bear workflow app, we can run npm run Android to build this for Android and run this on an Android device. And once this is done, I will do the same for iOS, of course. So I will be back once the Android build is done, because again, this initial build can take a bit longer. Subsequent builds will be faster, and just as in the Bear workflow, we will also have a process that watches our code and updates the running app with that code. We will only need to restart it if we add packages that tap into native device features. And with that, I'll be back once this build is done. So here the app is installing now. By the way, this npm run Android command now also opened a new terminal for me, which has the actual development server that watches the code and updates the running apps. So this is the process you should keep up and running when using this approach. And therefore now here I will also now run npm run iOS, since I'm on a macOS device, and I can do that therefore to build this app for iOS and to also run it on the iOS simulator. We will have one and the same development server running in this extra terminal that was opened up that will keep both apps updated as we change our code thereafter. If you're done with development for the day, you can always quit this, but you should keep this process here up and running until you are done. So let's wait for this iOS build to finish. Here we go. This is starting up on iOS. And with that, we also see the app here. And that's now a React Native app built totally without Expo, running on these two systems. And as mentioned, we have this development server. If we would change this text and save this, those changes are picked up and sent to those devices. So that still works as before, but now totally without Expo. The disadvantage is that there is even a bit more configuration we have to take care of. We now can't use the Expo Go app at all, not even theoretically, and we can't use those Expo packages just like that if we wanted to. But we're going to take a look at that, at using third-party packages, in the next lecture. So let's say we want to use some third-party packages that give us access to certain native device features here in these apps, which are built with React Native totally without Expo. Before, we could have, for example, used the Expo location package when using the managed or bare Expo workflows. But with React Native without Expo, that's not possible. Now, what you can always do is you can turn your React Native project into a bare workflow project so that you can use those Expo packages again. That is something you can do, and you'll learn more about this here in the official documentation. To be precise, you can search for bare workflow again, Expo bare workflow, and instead of creating a new project, you could now also add Expo to a project that was set up with React Native init, which is what we did here. You could run this command in this project, npx install -expo -modules, and this would install some core Expo modules, which then enable you to use other Expo modules like Expo location. So that would be possible. It would then be a bare workflow Expo project, but you need to do that if you want to use Expo packages. But of course, there aren't just Expo packages out there. You might not want to use any Expo packages, and then of course you don't need to convert your project into a bare workflow project. If you, for example, want to use the location service, if you want to get the user's location to your React Native app, you can search for React Native location, and on the official page, you will learn that you should use some community packages for that. Now, there are different packages, but the React Native geolocation service package is a quite good one in my experience. And you can use this package to get the user's location on both Android and iOS. It starts with installing that package, but then you also have various setup steps you need to go through. You'll learn more about them here, and as you see, you need to run pod install. Then you will also need to tweak some other things for iOS, including info plist, but not just this file. And for Android, you also have various steps you need to go through. Then thereafter, you could use this package and you could follow the usage instructions given here, or take a look at the example provided by this package to learn how you can use this package with Android and iOS. So that is how you could use such a package with a React Native CLI created app. And since this is not an Expo package, you don't need to install or use Expo in any way here. Now, I will not go through these detailed steps here because it's really just writing a bunch of code, which you can also find here. But the key takeaway is that some extra setup steps will be required, but that of course you can also build apps totally without Expo, as you can see at the example of this package. You can still tap into native device features with help of packages like this. It might just be a bit easier when using Expo. And that's it for this section. We now did have a look at the bare workflow and at projects that were created with the React Native CLI. We had a look at the differences and some advantages and disadvantages. Ultimately, it is of course up to you which workflow or which approach you want to use, but as you maybe saw, using Expo can often make your life a bit easier. There's less configuration you have to take care of, especially when using the managed workflow. Since you can eject from the managed workflow to the bare workflow anytime, there also is no good reason to not start with the managed workflow unless you know that you really need all that configurability and maybe you want to add your own native code. I can only encourage you to play around with those different approaches to build a pure React Native project where you maybe add a package like this React Native geolocation service so that you get a feeling for these different approaches and you see how they work, what's difficult, what's easy, and so on. What you learned in this course, and that's really important, will apply either way. All these core React Native components like view and text, React navigation, and also styling, all that works as you learned it. So that's not Expo specific at all. And as you also saw, adding third-party packages is also super simple and possible for all approaches. So therefore, what you learned will apply either way, but the differences can matter when it comes to ease of use, and of course configurability, as you learned. In this course, we learned how to build React Native apps both with Expo and without Expo. In this course section, we're now going to leave the development mode, and we are going to learn how we can publish React Native apps. Because of course, whilst you might build some apps for practice purposes only, chances are that you're also building apps that should be usable by other people in the world, that should be exposed to different users from all over the world. Maybe you even want to earn some money with your apps, and therefore, of course, you need to publish them. This is what this course section is about. It is about publishing React Native apps. For that, we will walk through the different steps that are involved in this publishing process. We will learn how we can configure our apps for production and which configuration settings are important and should be kept in mind. We will specifically have a look at adding icons and setting up a splash screen, a loading screen for our applications. And of course, we will then go through an example build process. And I will also show you this build process for both an Expo managed app, where this is super simple and convenient, as you will see, as well as for a pure React Native app that does not use Expo. So therefore, let's not waste any time and let's dive right in. So how do you publish React Native apps? And just to be super clear, publishing apps means that we put them into the Google Play Store or the Apple App Store. That is what I mean when I say publish apps. Well, we have to differentiate between Expo managed apps and React Native apps that don't use Expo. Now, very important, Expo apps include both apps that use the managed workflow or the bare workflow, about which I talked in the previous course section. So if you're using Expo in any way, you can benefit from certain advantages, as you will see. If you're not using Expo, you can of course also build and publish your apps, but it is a bit more cumbersome, as you will see later in this section. Now, if you're using Expo with the managed or the bare workflow, it starts with configuring your project. Now, there are tons of settings you can set, as you will see, but there are a couple of key settings you should be aware of. Once you did that, and this, by the way, also includes things like adding icons, but once you did that, you can move on and build the actual app binaries, the installable app files that can be installed on iOS or Android devices. And when using Expo, you can use Expo's Cloud Build service for free, which actually allows you to outsource that build process to the servers provided by the Expo company, so that the build does not take place on your machine, but on their machines instead, which of course means that you don't need to use your resources. If you have a slower computer, for example, you don't have to use that. And a great advantage of using this cloud service is also that Expo and their cloud service will build your app for different platforms, for iOS and Android, at least if you want to build the app for both platforms. If you would build the app locally, you could not build an iOS app on Windows, for example. That's a restriction applied by Apple. With the cloud service, when using Expo's cloud service and building the app on their servers, they will build both an iOS and an Android app in the respective environments, and therefore you get apps for both platforms even if you don't own a Mac. So that can be a huge advantage here. And then once the app was built, you can submit it to the app stores either manually or even again by leveraging a certain service provided by Expo, which makes this publishing process, this submission process, also seamless. So that's the Expo side. Very simple, as you will see, very convenient. Without Expo, you also need to configure your project in a certain way, and then you must build your app binaries locally, which means you have to build them on your machine. You might also find other third-party service providers which offer cloud builds, but you can't use Expo's cloud build service if you're not using an Expo project, at least not at the point of time where I'm recording this. So you then must build your app binaries locally, and in case of iOS apps, that means that you need a Mac device, because otherwise, as mentioned multiple times, you can't build iOS apps. And then again, you can submit those built app binaries to the respective app stores manually in this case, since we're not using Expo's cloud service. So therefore, this auto submission service, which I will show you later, will not be available here. So these are the differences. You can build apps either way. It will be a bit more convenient with Expo, but in this section, I will show you both approaches. So let's get started with building our app. And for this, let's first of all talk about configuring for production. So which kind of configuration settings might you want to tweak before you build your app? Well, a very important topic are permissions. Now, this of course depends on the kind of app you're building, but if you are using certain device features, like the camera or the user's location, then, as you saw before in this course, you might need to ask for permission, and therefore you must make sure that you got the proper permission configuration set up. Now, this depends on Android and iOS, and it also depends on which package you are using to unlock certain native device features. And I talked about permissions before in the course, and in the previous course section, I also show you what it means if you're not using Expo, that you then might need to tweak the info.plist file and the Android manifest.xml files in order to set up permissions there as well. So that is something to keep in mind, and that is something you saw before in the course already. Now, besides permissions, there also are a couple of other things that might need tweaking. For example, you might want to set an application name and a unique identifier, which is then also used by the app stores once your app was submitted to them. So you might want to set a visible app name, so the name your users can see, and then this unique identifier, and also give your app a version so that if you would update it in the future, you could update the version as well to show your users that the version changed. Your app might also be using environment variables or secrets, and those can also be managed by Expo, as you will see later in this section. I will talk briefly about all these topics in the next lectures. Last but not least, and also very important, you typically of course also want to set your own icons or splash screens. The splash screen is the loading screen when your app is starting up. And when using Expo, you get an icon and a splash screen out of the box, but you might want to bring your own, and therefore that, of course, is also something you typically want to configure and something we will take a look at throughout this course section. So with that, I'm back here in a project, and I'm back in this meals, in this food project we built earlier in the course, where we have multiple screens, where we can navigate between categories and meals and add favorite meals. This is the app I want to publish here as an example, or I want to build here as an example. And we will build this app with Expo since it is an Expo managed app. Now, talking about this, what we're going to use is the Expo Application Services feature provided by Expo. If you search for Expo EAS, you will find their overview page, and there, of course, you can learn more about those Expo application services. And if you are serious about app development with Expo, I do recommend that you do go through all these documents here and all these instructions in detail, because there is a lot you can do with EAS, and we're not going to dive super deeply into that here. But you can go through that to learn how you can configure and tweak every single aspect of your application. Now, this is the service we're going to use, and this is the service that will allow us to build the app in the cloud, and then if we want to, submit it again through the cloud directly to the app stores to make this overall build and submission process as seamless and easy as possible for us. Now, back here in the project, it starts with configuring this app though. And for this, we have this app.json file, which we used from time to time throughout the course, but at which we haven't really taken a closer look yet. And that's exactly what I want to do now. I want to go through some settings you can set here in this file and why they matter and how they matter. Now this app.json file is our key configuration file for configuring an Expo managed React Native app. In here, you can set things like the app name. And in general, the official documentation is a great place to dive deeper. If you have a look at the API reference, you will find this app.json reference, and here you find all the options you can set in this app.json file with an explanation of what this option does and an additional explanation if there are any changes if you are using the Bear workflow. Because if you are using the Bear workflow, you still have an app.json file, but you can't configure everything through that file. If you're using the managed workflow, which I am using here, then you can basically configure everything through that file. And it starts with the name, which is the name of the app as it appears in the Expo Go app, but also on the home screen as a standalone app. So that's the name users will see if they installed our app and they then see it on their home screen. So here, since this is an app about food and recipes, we could name it My Recipe Book. This could be one example name. Now the slug isn't too important for us here. This is more important if you want to publish this to other Expo Go apps, basically, if you don't plan on building this as a standalone app. And therefore this does not matter to us here. But what will matter is the version. Now regarding the version, if we take a look at the description here, we learn that this is the app version, which we set in addition to two other settings, iOS and Android specific versions. And this is related to versioning our app, which means communicating different versions we might be deploying. If we update our app, we want to set a new version. Now here, the important differentiation is that version. So this version, which we set here, is the user-facing version. That's the version users will see in the App Store as the version of our app. And it would, for example, make sense that if you're launching a brand new version of your app where you changed a lot, you maybe change this to 2.0 or 3.0. And smaller changes could be 1.1 or 1.0.1. So that's the user-facing version. It's just there to communicate to your users that you have a big change or anything like this. In addition, as we learn here in the official documentation, we also can set an Android-specific version code and an iOS-specific build number. And these are internal versions which are used by the app stores to basically tell different versions of your app apart. So version is seen by your users. These versions are internal but matter to the app stores. Therefore, we want to set those versions, and we can set the iOS-specific settings in this iOS child key here, which we have in the app.json file. So there we have some root settings, which apply to both platforms, and then we have iOS and Android-specific settings, and here in the iOS node, so to say, we can set the build number, as we learn here, like this, build number. And if we take a look at the app.json API reference and we scroll down here on the right, we can see the iOS specific settings here as well. And there we learn that this build number must match Apple's specified format. And we learn that this should basically be a string here and that it should look something like this. It should only contain numeric characters 0 to 9 and the dot character. So therefore, here we can set build number to a string, and this could be 1.0.0 as well, but it could also be a totally different number. It doesn't have to be the same as the version here. Now, if we also take another look at the explanation for Android and our Android specific settings, then here we got the version code. We can also learn more about that because that should just be a positive integer, as we can see here already. But again, we can dive into the Android documentation to learn more about versioning our app with that version code. But it should be a positive integer as we learn here, and therefore that is what we can set. So in app.json for Android, we can set this version code and set this to a positive integer, like 1. And the next version could be 2, even if our number may be only changed to 1.1. So that's how you version your app, and I'm going to start with one here. And as you can already see, when it comes to publishing and building your app, it's key to also dive into the official documentation. It's important to understand what you can configure in app.json because, as you see, it's a lot. You will not need everything all the time, but for some features you might be using, you might need certain configuration items. So you should definitely take the time to go through that if you are serious about building apps with React Native and if you are close to building and publishing your app. So that is how we can set this version. Now we also got more settings we can tweak here though. For example, we can lock the orientation, and here I'm happy with portrait mode. And we can also set an icon and also a splash screen, but that is something I'll do in a separate lecture. We can also configuring updates because Expo actually allows us to publish updates without publishing a new version in the app stores, but for the moment we can also ignore this here. In general, most of the default settings here should work for us, and therefore, as a next step, we can move on and take a look at some other settings which we don't need for this app, but which you should also be aware of before we then work on the icons and the splash screens. So which other settings can we set that we don't need in this app here? Well, as mentioned, there are a lot of settings you can set in app.json, so you might have settings that you need for your apps, but there's one specific feature I want to talk about which we don't need in this app, but which you will probably need in a lot of apps. And that would be environment variables. For this, if you go back to the EAS documentation, there you can learn a lot about setting up builds and running builds and configuring builds, and you can also learn more about environment variables and secrets. Now, environment variables are simply global variables which are set at the point of time of building your app or maybe even already during development, and then you might need them in different parts of your code. You also might have certain values that should be super secret, that should not be exposed as part of the code base. And Expo and EAS can help you with managing such values, so environment variables and secrets. And even though we don't need it here, I want to mention the documentation here about environment variables and secrets, where you learn about different ways of managing and setting environment variables and values that should not be exposed as part of your code base, because it is worth knowing and pretty important to know that Expo and EAS have certain features that help with dealing with such values. That's why I wanted to highlight this separately, because we don't need it here, but chances are that you do have an application that needs it, and then it's important to know that you got a solution built into Expo and EAS, and the official documentation makes it really easy to get started with that. Now with that, we're almost done, and this is a typo. This should be my recipe book here, of course. So with that, we're almost done, but now I want to work on the icons and the splash screens, which we see. And we got some icons and a splash screen set up out of the box in every Expo app we create. We find the assets for that in the assets folder. I mean, that's the path which we see here, assets and then icon PNG or splash PNG. And therefore, that's the default app icon we would get and the default loading screen. Not too useful, I would argue. This is what users will see on their home screen if they install our app. Of course, typically, you want to bring your own assets here. Now, the great thing about Expo is that all you need to do is replace these files, adaptive icon, which is Android specific, icon, and splash screen with custom files that have certain dimensions. The fav icon is only needed if you plan on building a web app as well, which I'm not doing here. Now, regarding the dimensions, if you search for Expo icons splash, you will of course also find an article from the official documentation where you learn about how such a splash screen can be added and how icons can be added, and you also learn about the dimensions that are needed. You also learn about the splash screen dimensions. So then you can design your icon and your splash screen and add this in the assets folder with the respective names or with any names of your choice. You then just need to update these paths and names here in app.json. The great thing about Expo is that under the hood, when you build your app later with Expo's cloud service, they will produce different icons based on your input icon for different devices and device sizes. Because if you ever build an iOS or Android app without React Native and without Expo, then you might know that you actually need multiple versions and multiple sizes of one and the same icon if you want to publish and build your app with Xcode or Android, because you want to target different devices with different resolutions. Expo builds those icons for you. It takes your input icon and then gives you different output icons. It doesn't give you those icons, but it builds them and uses them on the fly when you build your app. And that is really powerful and makes adding your own icons and splash screens a breeze. Therefore here, of course, I want to bring my own assets and my own icons, and hence I prepared something in advance, and attached you find an assets zip file which holds 3 PNG files which you can just drag and drop into your assets folder in the project and replace your existing files with my provided files. And this gives you a new adaptive icon, and splash screen. Now, you can definitely build more beautiful assets, but they should do the trick, and they are not the default assets, which is the key thing here. And with that, we also added all we need to add to get nice looking icons and splash screens. And with that, we now got all the configuration we need for the moment. We got our own icons and splash screens. We are now ready to start the build process with Expo and the Expo application service. So let's now start building this with the Expo application service. If you should feel lost at any point along the way, you can always go back to the official EAS documentation and then learn how to create a build. This documentation is always a great place to find all the explanations in written form, in more detailed form, and with extra annotations that you might need for your specific use case. In the end, what you need to do if you want to create a build is you need to create a React Native project with Expo. We already did that here. And you need to create an Expo user account, which you can do for free. You can even use this build service for free. So therefore, you should go to expo.dev and create an account here. And I will do this real quick, and I'll be back once I'm done. Now, once you created an account, you probably see an empty screen. Here I already got some projects which I worked on in the past. I already had an account before, so I already got some projects here. But either way, we can continue outside of the browser for now. We just need an account, because the next step is to install the EAS CLI and then use this CLI locally. So we can install it by running this command here in the terminal. On Mac OS and Linux, you might need to add sudo in front of that to get the right permissions. And this will install this extra tool on your machine, which is used to orchestrate and manage the projects and builds you want to build with EAS from your machine. So let's wait for this installation to finish. And once it is finished, we can continue by logging into the Expo account. For example, by running EAS login. So here we can run EAS login. And now we need to enter our email and username and our password. So here I did now log in, and with us logged in, we can now configure the project as we learn. So configure the project for building it. So for this, we can run EAS build:configure inside of the terminal, inside of our Expo managed React Native app. And then we get a couple of questions here, a couple of prompts. For example, which platforms we would like to configure. And here I will choose all, because I want to build this app for all platforms. And as mentioned, you can build for all platforms even if you don't have a Mac, because the build will not take place on your system. And as we can see here, I am already ready. What this did is it added a eas.json file here, which holds some extra configuration for this Expo application service build process. For the moment, we can keep the settings we see here. We will tweak them in a second though. Now with that done, we can run a build, but here I actually want to build an installable APK for Android or a build for the simulator. We could also run a build that's not installable on the simulators, but that instead is optimized for publishing it to the app stores. But since I would like to test the build project again before we send it to the app stores, I will go through these two steps here first to get a build that I can test again locally. Because there are different builds, the ones that are optimized for the app stores, which you can't install on the simulators or real devices before shipping them to the app stores, and the ones that can be installed. And I want to build the latter kind of version, the installable version, first. So therefore, we could start here by building APKs, which are these installable app packages for Android emulators and devices. And for this, we need to go through the settings we see here. And that's now where we need to tweak our setup a little bit. We need to set the build type to APK in our eas.json file. So there in the build node, in preview, we can add the build type node and set this to APK like this. And that's exactly what we also see here in the official documentation, that we want to set the build type to APK, though actually we need to do this in the Android sub node. So we'll just copy this and add it like this. So inside of build, inside of preview, and then there in Android, the build type is set to APK. And that is done in the eas.json file. Now we can run this command to generate such a build for Android. So therefore, we can copy this and give this a try. Here in the terminal, in our project, with that eas.json file saved, of course, so that these settings are taken into account, we can run this eas build-p android --profile preview command. Profile preview makes sure that this setting here is used, this preview setting, so this profile here in our eas.json file, and -p android makes sure that we only build for Android for the moment. So if we hit enter here, we now get a question. The question is what our Android application ID should be. And that is something I mentioned before already. We need to set app names, which are the human readable names, but also the versions, which we did, and unique app identifiers. The versions tell the different versions of our app apart, but the app identifier makes sure that our app is unique, that it can be uniquely identified, so that the app stores are able to tell our app apart from the other apps. And this identifier could have been set by us before in the app.json file, or we set it now when prompted for it. And here you want an identifier which is basically a reverse URL that is guaranteed to be unique. Therefore, what's often used here is something like this here, that you use your company URL reversed, so academind.com, because my company is called Academind and we own the Academind website, and now I reverse it to com.academind. And then a unique identifier for this specific app, because of course one and the same company could have multiple apps. Now, since this app is about recipes, I will name it my recipe book. So now this is a unique identifier for this app, and I confirm this. And after confirming this, this gets added to app.json. In app.json for Android, we now have this package key which holds this unique identifier. This was now added by EAS. We could have added this manually before. In that case, we wouldn't have been asked for it, but we can also set it like this. Next, we are asked for an Android key store if we want to generate an Android key store. And this is required for signing the app, so for securing the app and making sure that you are the only one who's able to publish it and publish updates to it. And you can either choose no and set up this key store manually, locally. Details about this are explained here in the official documentation. There you can learn more about building for Android and bringing your own key store if you want to. But here I will choose yes, which will basically make sure that Expo manages this signing key store on their servers, on the EAS servers. And then thereafter, our code is uploaded to the EAS servers, and there a build will be scheduled and our build will be produced there. And now this can take a while until the build is done there, especially since I'm using the free version of this service here, and there the build has a lower priority than builds of other customers who might be paying. Of course, you could also pay for EAS. If you're serious about using it, you might want to do that to get priority support and priority treatment. But here, I simply scheduled it, and looks like not a lot of builds were queued. So therefore here, my build is already in progress. And once this build is done, and of course this can take a short while, we will get a link to the APK file, which we then can download, install on a simulator or a real device, and which we could then also manually publish to the app stores if we wanted to. However, here, I'll first of all wait for this build to finish, and I'll be back once this is done. So now, after some time, my build finished here, and actually it didn't finish successfully the first time I tried it. I didn't show this to you though, because it was related to one specific package version. I had to fix React Native gesture handler to this specific version. It's very likely that you don't need to do this, but for me it failed. And I want to show you what you can do if this build fails, if you get an error message here, as I did initially. At first, my build failed. If that happens to you, you can go to your build details in your Expo account. There, you can go to this project, this R-in-Course project in my case, and view all your builds there. And then there you find build information, or information about that build, about the different phases, and then you see the failing phases, and in there you'll find some error messages, and there I was able to see that it seems to be related to this React Native gesture handler package, and I then simply tried a slightly older version and that worked. So that's just a side note. With that though, this completed, and now we can download the build file, the APK file, by following this link, or by scanning this barcode with an Android device, or from inside here, our Expo account. If we have a look at the successful build here, there I can also download the build artifact, so the file that was produced. I can click install here, and that in the end also gives me this barcode, or I can open this link on a device where I want to install this. Alternatively, we can also download this, and that's what I will do. I will download this file, and this downloads an APK file, which is this app that was built. Now, once this file was downloaded here, we can test this on a real device by simply dragging and dropping this APK file onto the emulator. Now here, it looks like I don't have sufficient storage, so I will quickly shut this down and then wipe the data on this emulator and restart it once the data was cleared so that we have more storage on that emulator. And then once this did start up again, we can drag and drop this APK file onto this emulator to install it there. And this installs the app on this emulator. We could test it on a real device by scanning this barcode you saw before. And once this installed, we can start our app from there. Now you can always tweak, of course, the icon and so on if you don't like the look, but this now gives you the app here on the emulator, and this is now the standalone app that we built with the EAS build service. Now here I did of course build in preview mode, that's worth noting, which means I built this APK, which is great for testing it on the simulator, but which is not optimized for the App Store, for the Google Play Store. There you instead want to use this production profile, which does not switch to this APK type, but which out of the box will use a more optimized type instead. And then you would get an AAB file, a different kind of binary file, which you could upload to the Google Play Store. You find more instructions about that here in the official documentation. We did now create a build where we get an installable file for our local machine. If we would build for app stores, then we would use the default profile, so we would not specify a profile when running EAS build, and that would then run the production profile, which produces such a AAB file, which is optimized for submitting it to the stores. As a side note, if you do want to submit your build files to the stores, you need to create the respective accounts. And in case of the Google Play Store, you, for example, also need to pay a one-time $25 fee. But then you will be able to publish your app to that store. Now you can also submit the app with EAS instead of uploading it manually by using EAS Submit. And you can, of course, also learn more about that here in the official documentation. I will not do this here though, because that really depends on your preferences and is simply not the focus of this course. The key takeaway is that you know that this EAS service exists and that it in the end makes building your app, and if you want, submitting your app, really easy. So that's there for the Android part. We were able to build this, in this case for the local usage. Now let's see in the next lecture how we can build this for iOS. So if our goal is to target iOS, we can of course again follow the official instructions. Again, I want to produce a file which I can install locally. And just as with Android, that means that we need to tweak the eas.json file. To be precise, we need to add this iOS specific setting. So again, in eas.json, where we also added the Android specific setting in this preview node, we now also add the iOS specific setting, which sets simulator to true. This ensures that we produce a build that can be installed on the simulator. Now, with that, you can start your build. However, for iOS, the build will be a bit more complex, or there are a couple of things you have to do. In the end, the command is almost the same though. The target platform just is iOS instead of Android. But you can then simply run this command here in the terminal in your project folder to start this build. Now, just as with Android, you have to pick an iOS bundle identifier, which is this unique app identifier that must be specified. And out of the box, it suggests the value which we also used for Android. And I want to keep that value. We should use identifiers like this for iOS as well. So I will just hit enter to confirm this here. And then this gets uploaded to the EAS servers so that the build can be produced there. However, this won't be all you have to do, at least if you're building for production, which is why I want to show this to you as well thereafter. For Android, the steps would be the same. You just would use the production profile or no profile at all. For iOS, there will be a difference. You can build this simulator build like this, as you see, but for production, you'll have to do a bit more, and therefore, we'll wait for this build to finish so that we can test this on the simulator, and then I'll show you what you will need to do for production. So here, this preview build also finished, and it also gives us a link which we can follow again. And when following this link, we get a zipped file that can be downloaded. And this file then, of course, can also be extracted. And once extracted, in there, we find a .app file, which can be executed on a simulator. Now, this only works on iOS because only there you can start iOS simulators. The build works either way, even if you're using Windows, but previewing this build, installing it on an iOS simulator, of course, only works on a device where you have an iOS simulator, and that is a Mac device. So with that, we can again drag and drop this file onto the simulator to find our app there. It starts with our splash screen, and then we will be able to use the app there as well. So this also works here on iOS, as you can see, and that's how we can preview it there. Now, what if we want to distribute it though? Well, then we need to generate a production build, and that works slightly differently. To build such a production build, or to generate such a production build, you first of all need an Apple Developer Program membership. You also needed to create an account with Google Play for these $25 if you wanted to publish an app to the Google Play Store. For Apple, you also need an account with them. There it costs $99 per year, I guess because it's Apple. There's no way around that. If you want to build production builds that can be published to the app stores, then you need this account. There is no way around that. So you can then create such an account, enroll, pay the fee, and once you did that, you will need to generate some certificates. Now I'll do this in a second, but first of all, let's actually start this build. For this, we can use this command, again, almost the same as before, just not picking a specific profile, and therefore we'll use the production profile out of the box. And if I do this, then here I get asked if I want to allow EAS to log into my Apple account. They are asking this because if I grant them permission, they will set up a couple of certificates and profiles, a couple of documents, you could say, that are needed to sign and build this app for production, that are required technically from Apple's side. Now I could type Y here to accept this, so I could enter yes, and then I would have to enter my credentials and they would log in and do this for me. Now I don't want to do that, so I will cancel the build here for the moment, and instead I'll set up these documents, these profiles and certificates which we need manually. Again, the official docs help with that because there you learn how you can manually set up these things, and you then learn which credentials you must create. You need a distribution certificate and a provisioning profile. So for this, I will log into my Apple account here. And once logged in, and keep in mind that you also need to pay that fee and become an Apple developer. But once logged in, you can go to Certificates, Identifiers, and Profiles, and we can start with a certificate and create one. We need an iOS distribution certificate, which allows us to distribute apps to the App Store, to the iOS App Store. And that's what we want to do here. Now, with that, we can click Continue. And continue by uploading such a certificate signing request file. Now we can learn more about that here. And in the end, we now need to go through these steps to produce such a file now. So I will do this on a different screen and get back to you once I have this file prepared. Once you walked through these steps, as I did now, we can upload this file. And once you picked your file here, you can click Continue. Now this will generate such a certificate which you can now download. So that's now another file which you can download. This file can be stored as part of your project, but should never be part of your source control. So here we could add a subfolder, certs/iOS, for example, to store iOS-specific certifications in there. And then you can drag your file into that folder. And you want to add this file folder, the certs folder, to gitignore if you're using Git, to make sure that this is not checked into source control. So that's the first file which we need. Then we can go back to our Apple developer account here. And again to certificates, identifiers, and profiles. And we now need to create a profile. Now what we need here is a provisioning profile. So that's what we need to create now. Now there are multiple provisioning profiles here. We again need an App Store provisioning profile here. So now we can continue again. And now we need to pick an app to which this profile should belong. Now you might not have an app here yet. And therefore, to get one, what we have to do as a first step is go back to our developer account and then there to App Store Connect. This is where you can create new apps, which can then be linked to the app file thereafter. So we have to go to App Store Connect and then there to My Apps. And here you can now build a new app, add a new app here, give it a name like My Recipe. What was my name? My Recipe Book. It's an iOS app, so I'll check this box. It's English, so I'll check this box. And here we now need to pick a bundle ID. So for that, we need to go back to this certificates page and register an app ID. Here you want to use this bundle ID, which you also set up in app.json for iOS. It's this bundle identifier. This should be grabbed now, inserted here as a bundle ID. And you want to enter a short description here, recipe book app. Click continue thereafter and register this bundle ID, this app ID here. By the way, sometimes you need to check more boxes if you use specific features in your app, but that's not the case here. So now this was registered. And back here in App Store Connect, if we now reload this page so that the latest information is fetched and we create a new app again, or we try creating this new app again, My Recipe Book. Now we should be able to pick this bundle ID. Here it is. We can choose full access, give this an internal identifier, recipe book, which would show up on sales statements and so on. And then click create. Now it turns out this name is already in use, so I will name this RN Recipe Book for React Native Recipe Book. Let's see if that works. Yes, it does. And now this app was created. Now we can again go back to our certificates and profiles and try creating a profile again. Here again, it's this App Store provisioning profile which we need. We can continue here. And now here we can pick this app which I just added, the Recipe Book app. Continue. Assign it to our distribution certificate, which we created before. And give this provisioning profile a name. And here it's the profile for this specific app, for the Recipe Book app. So I will choose this as a name. And then generate this profile and then also download this file. Now we have these two files, and I will drag and drop this file into my iOS folder here, this certs folder as well. So it should go in here. There. So now we have these two files in here, and now we need to make EAS aware of these files. Again, these are instructions which you also find in their documentation. In the eas.json file, we now need to add these iOS-specific settings for this production build profile. So I will copy that here and insert this here in this production profile. Now we need to set up our path, and I got almost this path, but it's basically inverted. For me, it's certs/iOS here. And then the provisioning profile name is this name. So we copy the full file name here and set this as a name here. And for the distribution certificate, as a first step, we need to execute this certificate file here. So I opened it in Finder and will execute this so that this gets added to Keychain. This is only possible on a macOS device again. If you are using Windows or Linux, you should let EAS manage those profiles and certificates for you. So answer this prompt, which you got earlier in the terminal, with yes instead of doing it manually, because this now only works on macOS. And then here we can add this to Keychain. And then once added in Keychain, you want to search for this certificate which you added a second ago. Then go to My Certificates here, and then export this item, and export it as a P12 file. That is something you should do. And this file should now be added into this iOS folder in our certs folder in our project. And now you need to assign a password here. Now here I'll pick a super simple weak password. Of course, typically you should use a stronger password here. With that, however, with all that done, now we got this certificate file here. This should now be copied, this name, and should be inserted here. So we should have certs/iOS and then this name here. And then here, this password which you chose. And here I have my weak one. You should have a stronger one. With that, we now set up those files locally. And keep in mind, you could have let Expo do this in the cloud. You could have let EAS do that in the cloud. And if you are on Windows or Linux, you should let EAS do that in the cloud if you want to build for iOS, because you don't have this keychain tool on Windows. So therefore now with that, however, I did show you the more complicated way of setting this up locally, which has the advantage that you don't need to let Expo or EAS log into your Apple account. With all that done, we can try running EAS build -- platform iOS again, and I get an error regarding those paths which I added. And yeah, that is an oversight from my side. This should not be added here in eas.json. Instead, you should add a new file, credentials.json, and add that setting in there. So add an empty object in there and then add those settings in here. That is what you should do. So slight mistake from my side, add this separate credentials.js file and add this setting in there, and eas.json does not need to be changed here. That is also what you learn here in the official docs, of course. So slight oversight from my side. With that, however, now we have set this up correctly. We can try this build again. Now again, it's asking me whether I want to log into my Apple account. And if I choose no here, it, at the point of time I'm recording this, still forces me to log in. So I will cancel this and show you an alternative way of forcing EAS of using my local credentials. What you can do to force EAS to use your local credentials, your local certificates, is you can set this credential source local setting in your EAS JSON file. In there, in the production build, we can add this credentials source local setting. And if I now run this command again, it's not asking me whether it should log in for me. Now it's asking me if I want to use push notifications, which I don't want to use here, so I'll answer with no. And now it's uploading this again to the EAS servers to start the build there. But now that build will be started with our own credential files here, and then this will produce an output that could be submitted to the App Store, either manually or with help of EAS Submit, which is that other service they are also offering, about which you can learn more here in the official docs. So we saw how we can build and deploy an app with Expo in the managed workflow, which was pretty convenient. Now let's say we have an app, for example, built with the React Native CLI. Here I'm not using any native modules, but if I were, I would have, of course, have updated my Android and iOS configuration files to request the right permissions and so on, and I showed all of that in the non-Expo module earlier in the course. So now let's say we're happy with the app and we want to publish it to the Apple App Store and the Google Play Store. Now the official React Native docs are a great place to get started with that. There in the documentation under guides, you also find this running on device guide, where you can learn how you build your app for iOS or Android on the different operating systems you might be working on. Important, you can only build for iOS on macOS now. Linux and Windows don't work because now we're not building the app in the cloud as we did with Expo, but locally on our machine, and there Apple has this restriction that you can only build iOS apps on a Mac. It is what it is. So, now what you need now is an Apple developer account. Right now, not necessarily a paid one, just to build the app. However, if you want to build it for the app stores, you need a paid one, as mentioned earlier in this module. So you should set up such an Apple developer account and then open your project here, your iOS project to be precise, with Xcode. There you can click open another project, go into your project folder, there to the iOS folder, and there select this XC workspace folder or file here to open this with Xcode. This opens your project, your iOS project, which includes your React Native code, of course, in Xcode. Now it's there where you now configure this app, where you set up your identifier, for example. That's this inverse URL I was talking about, which could be com.academind.rn no expo test, something like this, where you set up version numbers, which your users will see, and your build number, which can simply be a number that you increment here, where you should choose automatically managed signing, and where you now need to choose a team, which should be shown here. If not, add an account, and there log in with your Apple ID to add your Apple developer account as an account here. And thereafter, you should be able to choose your team here, which will be required for automatically signing the app, which will then be done by Apple, so to say. You can, in general, configure your app here, of course, and prepare it for deployment. And one important configuration is, of course, related to the icons you want to use. In Expo, we set up the icons conveniently in a configuration, and Expo generated all the icons for us. Now it won't work like this. Now you need to set up these icons on your own. And you do this by clicking on this little arrow here, which takes you to the assets catalog. And there you can now provide icons, and you need to provide icons in different sizes here, as you can tell. And obviously that was a convenient thing by Expo. It did create these icons for you, and you didn't have to manually create all these icons. Attached, however, you find the icons zip file, which includes icons you can drag and drop in here. So that's what I'll now do. And the icons are labeled such that it should be clear what you have to drag where. And with that, you got the icons configured. You also might want to configure the launch screen. For that, you can expand this folder, and there you find this launch screen zip file. This in the end allows you to customize your launch screen. There you can add new widgets to it, drag images into it, change the text you see here, for example, and configure the launch screen in general. You can learn more about this in the Xcode docs, of course. And once you did configure all of that, you can build your app here. For that, you can also, for example, test it on a simulator first by choosing a simulator version, then clicking the play button here, and this will now build your app and run it on the simulator. And thereafter, of course, we can also build it for deployment. Let's just see whether this now all works. It launches this bundler process, which you already saw earlier for this standalone app, because of course that's still part of the development experience here. It's still a React Native app after all, which you use for building this native app. And now this succeeded, and it launches the app on a simulator. Now I'm not too interested in the app there because I, well, only have a very basic app there which doesn't do anything fancy, but this proves that building works. Now in the official docs, if you scroll down further, still in this running on device section, you also learn how to build your app for production, if it's a non-Expo app. And there we have got two important things to do. The first important thing is that in our project view here, by clicking on this folder and then on this icon here, you expand this folder and then go to the info plist. And now there you'll find this app transport security settings key. This kind of controls how iOS controls to which web pages or web servers your app may talk. And by default, it only allows access to HTTPS servers, so SSL secured servers. That's a good default, but you might have some exceptions which you can add here. And one exception in the exception domains list is localhost. Now that's required for development because your React Native app in the end talks to this development server here, which runs on your localhost, which is not using SSL. Normally iOS would block this. Now to not block it, this is in the exceptions list. To build this for production, you should remove this. You can simply clear this key here by removing it with the delete key. And that's it. That's one thing you should configure for deployment. And then you need to configure such a release scheme. For that, you should go to Product, Scheme, Edit Scheme, and set this from Debug to Release here for Run, and then close this. With that, you can now run Product, Build here, to build your app, and now this is built for release, built for production, so it's optimized and so on. So this builds your app now for production. Now, whilst this build runs, let's make sure we can also upload it to the Apple App Store. And for this, you should go to your Apple developer account, and here you now definitely need a paid account. And there, you now need to set up a couple of things. You need to go to Certificates, IDs, and Profiles here, and go to Identifiers, and then here add a new app ID. Just this here, the first setting, add an app ID. And you need to add the app ID, which you set up in your project. So the app ID, the bundle identifier you find here, that exact identifier needs to be added here. You can add a description, RN demo, whatever you want. But then here you need to add this ID. Now you can check any special capabilities your app requires, which my app doesn't, so I don't need to check anything there. And then I can continue, confirm this, and register. Now this is required, otherwise you won't be able to publish your app. Now with that ID registered, you need to go to iTunes Connect, and you can simply Google for that, which is in the end the service where you create that store page and where you now need to, well, set up your app. There you can go to My Apps and add a new app here by clicking the plus, new app. Here, by the way, you also see the app we built with Expo, so click new app here. iOS, give it a name like RN No Expo, which of course is a beautiful name, which you wouldn't really want to use, but it's good for us here. Then choose the language you're building your app for. Choose the bundle ID, and there choose the ID you just set up. If it's not showing up yet, come back a couple of minutes later. It will be there then. You can then also add your own custom identifier, which will show up on your invoices basically and so on. RN No Expo, whatever you want. And click Create. And this now creates the app here in iTunes Connect. This is then also where you can manage the app for the App Store and set up its pricing, and so on. Now with all of that done, let's wait for our build to finish here. And if it failed, like it did for me, reason for that is you need to set this to generic iOS device. So make sure you have this set. Also make sure that on this RN without Expo tests, you select your development team. That's another error I got here. If you're still getting an error, as I do, press Command 1 here in Xcode. Click on Build Settings here with all these things selected as you see it here. In the linking section, which you'll find if you scroll down a bit, and in the dead code stripping part here, under Release, set this from Yes to No. This is a workaround around this error, which seems to be related to the automatic tests which are set up. And once you did this, try this again, run the build one more time, and now this should succeed. Once this build succeeded, you can go back to product, and now the archive option is available. If you now run this archives your app, which is nothing else than building that bundle which previously was built on Expo's cloud servers. So let's wait for this to finish. Once this is done, you should see your archive, or archives if you ran the process more than once, here. And now here you could distribute your app to the App Store with the configurations made on iTunes Connect and so on, which I showed earlier. Now I'll not do this here, but this is how you would deploy your React Native only app without Expo managed. Now you learned how you can build your app for iOS. What about Android? Again, in the official React Native docs under Guides Android, you'll find the instructions on how to publish your app to the Google Play Store. And in the end, you can just follow the instructions you find here. It all starts with creating such a key store, which I already mentioned in the Expo managed workflow, but there Expo did that for us on their servers. Here we need to do that. And we can do this inside of our project, or on Windows, as it says here, make sure to run this command while navigated in this folder. You can copy your key store into your project thereafter, or store it anywhere else. You will need that key store which is generated for signing your app and for signing updates to the app, so make sure you don't lose it, otherwise you'll not be able to, well, rebuild your app or update your app. So here you can enter an arbitrary password which you want to choose, and then some information about you, which technically could be wrong, but which, well, should be correct, kind of, since this is your identifier, since this is used for assigning your app in the end. And once you had entered all this and confirmed it, and you chose your passwords, this now creates this myUploadKey store file here. And now you can use that to sign your application. Next, you need to set up some Gradle variables, as you see here. And for that, make sure you move the key store into the Android app folder. So from this folder here, move it up into Android and there into the app folder so that the file is there. And then go to the Gradle properties file, the Android Gradle properties file. So here under Android, we have the Gradle properties file. And in there, you can add these entries. And as it says there, replace the stars here with the password you chose for the key store. Once you did that, you can close that file. You should go to the Android app build Gradle file. So not build Gradle here, but in the app folder, and there the build Gradle file. And add this configuration in the Android node, as you can see. So you can just copy this, and then here search for the Android node, which is this node. There you got the default config, which you should not touch, but you got your signing config, where you should, in the end, add this release part. So not delete the debug part, but add this release part. And then under build types, release, add this line here. So if we scroll down further, build types, release, there we can add this line, signing config, release. And now you can generate your APK with these commands. So by navigating into the Android folder and then by running this command. Let's do that. Let's first of all navigate into the Android folder here with cd Android and then run this Gradle w command. And this should now build your app and sign it for production and give you such an app bundle in the end, which you can then upload to the Google Play Store. So let's wait for that to finish. And once this build succeeded, you can actually take that app bundle, which you now find under app, build, generated, outputs, bundle, this file here. That's your release bundle. That's what you can now upload to the Google Play Store. For that, you can search for Google Play Console, and you need a Google developer account for that, which also costs you money, but unlike Apple's program, it's not a subscription, it's a one-time fee of $25. And here in the Google Play Console, you can now create a new application once you're logged in with your paid account. Choose an app name, like this, create it. And then here you can manage your entire store appearance, your entire app, how it looks like. And under app releases, there you can click on production track, production manage, create a release there. And now here you need to upload your app bundle. Now you can click continue here with the default settings normally, but in general I would recommend that you dive into the Google Play Store, Google Play Console documentation to learn all about the things you can set up here. But in the end, this is now where you can upload the bundle which you built. So here you would upload this bundle file. And thereafter you can finish up your store appearance and you can publish your app in the Google Play Store as well. Now of course you might wonder, how do you add icons and so on? Because I haven't touched on this yet. A convenient and easy way of doing that is with the help of Android Studio. There you can open an existing Android Studio project and open your Android folder in your React Native project here with Android Studio. Just the Android folder, not the entire React Native project. In there you find your Android part of this project. And here to add icons, you can go to the app folder, source, main, res, and there wait for this initialization and the build to finish, which starts up when you opens this. And once this initialization is done, in that app folder, if you click on the res folder, right click on it, you can select new and there image asset. And this opens an editor where you can conveniently add and generate new image assets, new icons, for example. There you can choose launcher icons, adaptive and legacy. And now what you can do, you can leave the name, you can set up your icon, you can configure it there. You can choose a foreground layer, and there you can, for example, choose the path of an image you want to use. A background layer where you can set a solid color or also an image you want to use in the background. And then therefore generate your icon with that tool. Simply click finish and of course provide your own image there if you want to, and it will set everything up for you to have a nice icon, which of course is pretty sweet. Now regarding how to customize the splash screen, attached you find some documentation on how you may do this on Android to set your own splash screen. Of course, whenever you change your icons and or your splash screen, you'll need to rerun this build with that Gradle W command, and then also redeploy your new app bundle to the Google Play Store with the Google Play Console. And with that, this is how you would build and deploy React Native only apps. Of course, a bit more manual work, a bit more cumbersome than in the Expo managed workflow, but now you know both options and you can go for whatever approach you need for your application. In this course section, we are going to explore push notifications, or to be precise, notifications in general, because as you will learn, there will be a difference between local and push notifications. And we'll actually start by learning how to work with local notifications and what local notifications are, before we then later in this course section also explore push notifications. And you will learn what it takes to implement and add push notifications, and you will of course learn how push notifications actually work and are added to an application. And you will see this at a basic example where I will show you how you can both trigger a notification to be sent to other devices and how you can handle incoming push notifications. Now let's start diving into notifications, and as mentioned, we'll start with local notifications, and for that of course we need to understand what exactly local notifications are. As a side note, the concept behind local notifications is also related to push notifications, so what you learn now about local notifications will also help you later when we dive into push notifications. Now, local notifications are simply notifications that are triggered by the installed app on the same device on which the app is installed. So these are notifications that are not sent to any other devices or users, but which are instead triggered by an app for the device on which that app is installed. And you can simply schedule such notifications from inside the app, and you can then also configure the delivery and what should happen when such a notification is received on the device. And you might wonder why you need such local notifications. Because whilst it makes sense that you can send notifications to other devices, for example when a chat message was received, it might not be obvious why you might want to send notifications to yourself. Well, think about apps like a reminder app, or maybe an alarm clock app, or a to-do app. Of course, it might not make too much sense to send yourself a notification that is delivered instantly, but scheduling a notification to be delivered in the future, for example when a to-do becomes due or when a reminder becomes due, that might make a lot of sense. And this is what we'll start with, and as you'll see, adding such scheduled local notifications is really straightforward with React Native, especially when using Expo. Now to get started with our notifications, I'm in a brand new project. It's the same dummy project we used multiple times throughout the course, nothing special about it. And in this project, I want to add local notifications. I want to make sure that we can send ourselves these local notifications or that we can schedule them. And it turns out that this is very simple, as I mentioned, when you're using Expo, which I do in this project. When using Expo, then you can use the Expo notifications package. And this package makes scheduling and handling notifications super simple, and it's a package that can be used for both local and push notifications. So we will use this package throughout this entire section, at the beginning for local and later for push notifications. And this package also again shows us why it is so useful to use Expo with React Native, because implementing push notifications in a non-Expo app is of course also possible, but will take more configuration steps and can be more annoying. That's why I do recommend using Expo and this package specifically when building more complex apps that, in this case, also need notifications or push notifications. So this package, of course, has its official documentation, which I do recommend to check out if you do plan to add notifications to your app, because there are a lot of details that can be configured and set. But it all starts with installing that package. By the way, you also see some compatibility information here, and you see that, for example, for local notifications, we will be able to test this on all our emulators and real devices, but we will also see that for push notifications, which we will explore later in the course, we will not be able to test those on the Android or iOS simulators, so we will need real devices for that. But again, it all starts with the installation, so with Expo install expo-notifications, and that is therefore what I will execute here in this project. Expo install expo-notifications to install this package into this Expo project. And as mentioned, this package will help us implement notifications. Now, once this was installed, we can start using it, but before we use it, it's always a good idea to check out the configuration documentation that we find here in the Expo documentation. And we can see that there are various configuration steps that might be relevant to us. However, it is a good idea to take a closer look at that, because actually not all configuration that can be added might be needed for us. For example, here we learned that we can configure this package in a certain way to, for example, customize the icon that's showing up when a notification is received, the color that's used for the notification, and some sounds which will be played back when a notification is received. And you also get additional instructions for bare React Native projects, by the way. You can use this package there as well, but you got extra installation instructions which you should go through if you do plan to use this package in a bare React Native project. So for the moment, we can ignore that. We can add this here in our app.json file though. We can copy this plugins item here and then go to app.json and then add this here, maybe at the bottom like this, add a comma here, to set some sounds and colors. However, here I don't have any sound files and I don't want to use them, so I will remove this. And for the icon, I will simply point at my standard icon here, so I will just replace this with icon PNG. It is also important to recognize that these properties don't have to be set, and for example, the icon and the color, these two properties are Android only, and therefore they don't have any effect on iOS, for example. But you can configure this however you want. Now, in addition, if you plan on using push notifications instead of local notifications, with which we will start, then you might need extra setup steps if you're not testing this in Expo Go. Now, we will start with the Expo Go app, so we actually don't need to go through these extra setup steps, But you should keep these steps in mind for later when you plan to build your app. And if you want to distribute it through the app stores as a standalone app, then you will need to go through these extra steps here, through these extra guides, if you implement push notifications. For both Android and iOS, you need to go through these guides. But for the moment, again, we don't have to do this. And here under permissions, we learn that actually this permission is added automatically. So we don't need to do anything here for Android. And for iOS, we can check out this extra article to learn more about permissions. And we do learn that we will need to fetch the permissions in code later when we plan to react to notifications and work with notifications. But I'll come back to that later. Now we also got some common gotchas you might want to take a look at, but with all of that, we're then ready to get started. And as mentioned, we will get started with local notifications first, before we then thereafter switch to push notifications. So let's get started with local notifications. For this, I'm back in this project, in this starting project I set up. And I will stay in app.js for this because we're not going to build a fancy app. Instead, we're just going to focus on these core notification features so that you can learn about those without having to build a complete app again. So therefore, here I actually want to start by showing a button which, when pressed, should actually schedule such a notification. So for this, I'll import button from React Native and add a button here where I say schedule notification. And then the goal is to do just that, to schedule a local notification. Therefore, in this app component function, I will add a nested function, schedule notification handler, could be the name. And on this button, I will add the onPress prop to point at the schedule notification handler so that this function will be triggered. And now to schedule a notification, we have to import everything as notifications from Expo notifications. That's also what you find in the official docs. That is how you get access to the various methods exposed by this package. So with that, we import this. And now here in schedule notification handler, we can use this notifications object, which we are building here, to then call the schedule notification async method. And this will schedule a local notification, and async simply means that this returns a promise in the end. Now this method here, which we're calling schedule notification async, wants an object where we configure this notification. It's an object that takes various properties. To be precise, it takes a trigger property, an identifier property, and a content property. Now, as always, you can learn more about that in the official docs. There, if you search for this schedule notification async method, you'll learn more about the configuration at once, and you'll learn how the trigger and the content can be configured, for example. You can also dive into the full type definition of this request object to learn about all the possible settings that can be set up there. So here what I'll do is I'll add a content key, which again wants an object, and now here again we can configure the content of this notification. Now as you see, there are a lot of properties that can be set for the content. Again, you can learn all about that here in the official docs. I want to highlight though that some of these settings will only work on Android and some settings might only work on iOS. What can always be set though is the title. And here I want to set the title to a string, and you should set it to a string, which sets the title that will show up in the notification when it is received on the device. So here I'll say my first local notification. In addition, after setting the title, I'll also set the body, which also wants a string. And here, the string can be set to this is the body of the notification. So that will essentially be the detail text that shows up inside of the received notification. We can also add some extra data which will not be visible when the notification opens up, but which can be extracted when we then handle the notification in code. And here you can set an object with any key value pairs of your choice. For example, username Max. And we will be able to extract this when we then later handle the incoming notification. Now, besides that, there are more properties that could be set. You could, for example, again set a sound that should be played for this notification when it's received, a priority which is handled or which is respected by the device to tell the device how the notification should be displayed and how it should be prioritized compared with other notifications that might be scheduled, and so on. The best idea always is to also play around with these various properties to get a feeling for what they do. Now that's my content here, however. As a next step, we have to set a trigger. Trigger also takes an object, and in this object, you basically configure when this notification should be delivered. And what you should set on this trigger is actually the seconds property, which configures the number of seconds until this notification will be delivered. And here I'll set this to 5 so that we don't have to wait too long. Now with this all configured, if we now go back to our applications and we give this a try on Android and we wait for 5 seconds, then we will note that nothing happens. We can sit here forever and wait, but we don't get any notification. No notification is received here. Well, actually it is received, it's just not displayed, and that's therefore what we'll take care of next. So how can we make sure that we don't just send or schedule notifications, but that we're also able to handle them? Well, again, with some help from that notifications package. At the moment we're scheduling notifications, what we now also need to do is set up some logic for handling them. And for this, outside of the app component function, but still here in the app.js file, so that this code is executed whenever the app starts up, in that place, I will access the notifications package and then the set notification handler method. This method must be executed to tell the app and therefore indirectly the underlying operating system how incoming notifications that are related to this app should be handled. And notifications scheduled by this app are associated with the app. So this handler defines how such notifications should be handled by the device. Now we execute it here outside of the component function because this does not need to run whenever this component is updated. It should just run once when the app starts. And here in app.js, since this is our root entry file, this is guaranteed to run when the app starts. Now set notification handler wants an object. An object where we can set a handle error, success, and handle notification method in the end. Handle notification will be triggered whenever we receive a notification. Handle error and success will be triggered based on how the notification was handled, if it was handled successfully or if some error occurred. But handle notification is required, it's not optional, because this is the starting point to set up how a notification should be handled in general. Handle error and success can only become relevant if handle notification was implemented before, because we can't handle a notification with an error or successfully if we haven't handled it at all. So handle notification is added, and handle notification actually wants a function as a value, a function that should yield a promise, which can be achieved by adding async here. If you hover over it, you see that a promise is expected here. So by adding async here, we make sure that this function always returns a promise. And then in this function, we want to return another object. So we want to resolve to this object in the end, where we can set a couple of key properties. Like should play sound, should set badge, and should show alert. All three properties are needed. Now, should play sound is obvious. It controls whether a sound should be played. We can set a sound here when we schedule a notification, or in app.json for our notifications in general, but we can still control whether we want to play such a sound that might be attached to a notification. We can still suppress the sound here. And I'll set it to false indeed. With should set badge, we can control whether a badge should be added to the app icon if we get unhandled notifications, and here I'll set this to false. And with should show alert, we control whether such a alert should be shown on the device whenever a notification was received. And I will set this to true. And that's now crucial. With this configuration added, we make sure that whenever a notification is received, for example, because we scheduled one, we will also display it on the device. So if we now reload this app here with those changes saved, and we then go back here and schedule this notification again on Android, then we will see that if we now wait for 5 seconds, we got this new notification here. My first local notification with the body of the notification. So that's of course this data which we set up here. So now this works. And we can also test this on iOS. If we click schedule notification there, if we tap this button, and we wait for the 5 seconds, we also get the notification here. We can then also interact with it. I'm just dragging it here so that it stays open. And we can see the title and also the body. And of course, we can also tap those notifications. If I schedule another one and wait for it to arrive, I can tap it here. Or also, if I wait for it to disappear, I can tap it in this drawer. And if I tap it, then we can handle this notification. However, that part is still missing right now. Right now, the only thing we do with notifications is that we show them, but we can do more with them. At the moment, we can schedule notifications and we can then see them here. We can see them on our devices, but if we tap on them, nothing happens at the moment. If we interact with such a notification, we go to the app, yes, but besides that, nothing happens. Sometimes this is all you want. Sometimes the only thing that is required is that the app is opened up when a notification is tapped. But sometimes you want to do more than that. Sometimes you want to execute some code in your application when a notification was tapped, or maybe when it was received, no matter if it was tapped or not. And that's also possible with Expo notifications. With that import, which we already have, we can add some event listeners where we listen to incoming notifications or to the user tapping on incoming notifications. And we can register such event handlers with useEffect, for example. useEffect is a good way of adding event listeners that should be added when this component is rendered and that maybe should be removed when this component is removed from the screen. Even though the app component will of course never be removed, but you could set up event listeners in any component, so it is a good practice to also handle event handler removal to avoid memory leaks. So here I'm calling useEffect, and of course useEffect has to be imported from React though, like this. And with it imported, we can add our effect function here and our effect dependencies. Now at the moment I have no dependencies, but here in the useEffect function, I will call notifications add notification received listener. So no matter whether a user tapped on a notification or not, this method allows us to register an event handler function that will be executed whenever a new notification is received by the device. So here we pass a function to add notification received listener. And here I'll just pass an anonymous arrow function. Of course, you could also point at some other function that's defined somewhere else. And this function will receive a notification object that contains some information about the received notification. And for the moment, I will just console log notification received. And then below that, I will console log this notification object that we're getting here automatically. So this will be passed in automatically because Expo will in the end call this function for us, you could say. This function will be called for us whenever a new notification is received. Now, add notification received listener returns a subscription object, which we can then also use for cleaning up that subscription to this event. So to clean up and remove this event listener whenever we don't need it anymore. We can do this by calling subscription remove. And we should call this whenever this component is removed from the screen, when it's not active anymore. Now, as mentioned before, the app component will always be active. Still, it's a good practice to make sure that this method is called when the app is removed or when the component in which useEffect is triggered is removed. And you can do this by returning a function from useEffect, which will be executed automatically by React whenever this effect is run again or cleaned up because the component in which it was placed is removed. And therefore, it's inside of this cleanup function where we want to call subscription remove. And this is just standard React. It has nothing to do with React Native or notifications. So now with that done, with that listener added, if we now trigger this notification again, and it does not matter whether we do this on Android or on iOS, once we got the notification, we can see in our terminal that we see this notification received output, and then we get this notification object. And as you see, it's a quite complex object with lots of data in it. And we, for example, get the date in milliseconds. We also see the request object in there, which contains the content of the notification. And there we find things like the body, but of course also the title, and a couple of other fields that could have been set when we called schedule notification async. You might recall that we had more properties here. Some of these properties can now be found here in this received notification. We also get an identifier, which is a unique ID for that notification. And with that, we can of course then also get any data out of this notification. And one of the most important fields related to getting data out of the incoming notification is this data node, which we have here in this request object and then in the nested content object. This data object, this nested data object, contains some data that's added by default by Expo. We can ignore this, but we also see this data here, the username. And that is the data I set when I scheduled the notification before. So this is this invisible data, so to say, which is carried along with the notification, which is not visible when the notification opens up on the device. So this is not directly visible to the user. But of course, it is data which we could now extract and use in our code whenever a notification is received. We could dive into this notification object, into the request and the content object there, and then into the data object to extract username, this username field. And we would get this username, and we could of course then also console log this username here. We can console log this here and extract it like this. So if we do this and maybe reload everything, if I now schedule this notification again, and we wait for it to arrive here on iOS, the same would be true for Android though, then we get this username in the terminal down there as well. So that's how we can handle received notifications no matter whether the user interacted with them or not. But we can also react to user interaction. If we want to listen to user interaction with our notifications, so if we want to react to a user tapping on a notification, we can also do this by adding such an event listener. The name of the method that adds the listener is just slightly different. But still here, in this useFact function, we can call notifications add notification response received listener. Before it was add notification received listener, now it's add notification response received listener. And response simply means that the user responded to the notification by tapping on it. Now, just as for add notification received listener, this method also wants a function as an argument, and this will be the event handler function that will be triggered whenever a new response is received. And therefore here we get a response object, which is almost the same as the notification object we got up here, but it is different in some details. So as a start, simply console log notification response received here, and then log the response object so that we can look into it and see what's inside of it. Now, just as the add notification received listener, the add notification response received listener also returns a subscription. And to avoid name clashes, I'll name this subscription 1 and this one subscription 2. And we should use this for cleanup as well. So we should call subscription 2 remove and subscription 1 remove in this effect cleanup function. With that, we can give this a try. We can save this all and reload. And now if we try this on Android maybe and we tap on this, we get this new notification here. I also still have an old one, but we got the new one. And if I don't tap on it, then we only got the output from before. So we have the notification received event handler function doing its thing and logging this object, but we don't see notification response received because we haven't tapped this item yet. But if I do now tap this notification, I am taken back to the app. That's the default behavior of the operating system and the device to load the app to which the notification belongs. But we now also see notification response received being logged here, and that's coming from our second event handler function, and we see this response object. As mentioned, it's very similar to the notification object from before, but it's essentially an extra wrapper around the notification object. So in this response object, we got a notification key, and that notification key contains a notification object that has the same shape as the notification object we got here in the other event handler function. But in addition to this notification key, we also got this action identifier, which basically holds some extra metadata. But that's it. Other than that, there still is all the notification data in there, and hence we can also get our username here by diving into response.notification.request.content.data.username. And with that, if we save this again and reload everything again, maybe to clean up the terminal as well. If I schedule this on iOS again to also show that it works there, if I then tap on this notification, I also see Max here, and that's being logged here by this line, as we can see, because we also got this notification response received output here. So the event handler works for iOS as well. And that is how we can react to incoming notifications and to user interaction with those notifications, in this case for the local notifications. But I can already tell you for push notifications, this code will be the same. The only thing that will change is that we will need to get some extra permissions and a push token and how we trigger the notification. That will change as well. But handling notifications will be the same no matter if you're dealing with local or with push notifications. And here we worked on local notifications. So we did explore local notifications, which means basically that we're talking to ourselves. We're triggering the notification from inside the app with some code, and we're handling the notification inside the app as well. And it's the same app on the same device that's sending notifications to itself. But as mentioned before, this can be useful if you're building something like a reminder app or anything like this. But of course, you also often want to talk to other instances of the app installed on other devices by other users, and that's where push notifications come into play. Because push notifications in the end allow you to push important, guess what, notifications, so important messages in the end, to other devices to notify users of something. And the something could be a chat message, but it could also be a marketing message sent by the owner of the app to all users of the app. That would be another example for a push notification as well. But it's very important to understand how exactly push notifications work and what sets them apart from local notifications, though the latter might already be clear. But how do they work? Well, we have our app installed on some device, and this app might be talking to a backend owned by us, to some backend API, but this is not mandatory. This is possible, but not required. But of course, in many apps, you will have some backend where some data is stored or some logic is executed. Either way, if you have a backend or not, your app will be doing things. For example, there might be certain events that occur in your app. Maybe a chat message was sent if it's a chat app. Events might also occur on your backend, though, if you have one. Again, it's not required, but if you have a backend, events could occur there as well. Either that chat message that's being stored in a database, for example, that could be an event that occurs on the backend. Or maybe you as the app owner decide to send a marketing message to all installed instances of your app, so to all users of your app, therefore, and that of course also would be kind of an event occurring on the backend, that you as the owner decide to send a marketing message. Either way, upon certain events, you might want to send a notification to other instances of the app installed on other devices, either because of events that occurred on the app on one device or because of events that occurred on the backend. So the goal with push notifications is to send messages, notifications to other devices, so to your app installed on other devices. And this could be one device that's being targeted, but it could also be multiple devices, maybe thousands of devices. This really depends on the kind of message. If you're sending a chat message to a friend and you want to send a push notification to that friend's phone to make him or her aware of that message, then the push notification will be sent to one device, probably to your friend's device where the app is installed on. Of course, if you're posting into a group chat, a push notification might be sent to multiple devices for all your friends that are in one and the same chat group. So it depends on the kind of message to how many devices it is delivered, but the idea behind push notifications always is that it's being delivered to a different device than the device on which it originated, so on which the event occurred. So we want to send such a notification either from one app instance on one device to another app instance on another device, or from our backend to some devices. But this is not possible like this. Our apps and also our backends can't directly send notifications like this to other devices. This does not work. This does not work for security reasons and also to prevent spam and so on. And therefore, both Google and Apple, in the end, both force you to use some backend provided by them to send push notifications to other devices. So you need to go over some push notification servers to send those notifications. Now, Apple and Google force you to take this extra route, but actually such push notification servers are also provided by other providers, for example, Expo. Under the hood, though, Expo is talking to Apple's and Google's servers. But using servers like Expo's push notification server allows you to talk to one server to send push notifications to multiple devices running multiple operating systems, so to Android and iOS at the same time. So therefore, you must send a message, a HTTP request in the end, to such a push notification server to have that server deliver a push notification to the devices where your app is installed. And you can send such a request to the push notification server either from inside your backend code, if you had an event that occurred in your backend code, or directly from inside your app. And I will show you the latter in this course section, but both approaches are possible. And then it's the push notification server, and under the hood, therefore Google's and Apple's servers, that will actually reach out to the actual devices and deliver the push notifications to those devices. And then on those devices, the notification will arrive just as the local notification arrived. So there you can handle it in the same way as mentioned before. But it's delivered to those devices from Google's and Apple's push notification servers, which in turn can be targeted with help of Expo's push notification server, simply to simplify things. So that's the big picture, and if it's still not 100% clear yet, that's no problem, because we're now going to walk through all steps you need to go through to send such push notifications step by step over the next lectures. Now, to get started with push notifications, I always recommend diving into the official documentation of the tool you're using as well. I'm going to show you all steps throughout the next lectures, but still, it's a good idea to search for Expo push notifications so that you find their documentation where you get detailed instructions on how to send and handle push notifications. At the moment, this is split across multiple articles which talk about setting everything up for sending push notifications, and then how you need to send push notifications. Here you also find examples and instructions for how you would trigger that from some backend code. So how you could send push notifications from your backend code if you had a backend. But you also find a URL, an API endpoint, to which you can send requests from inside your app code, for example, to deliver push notifications to other devices. But again, we're going to go through all of that step by step throughout this course section. And of course, it all starts with the setup. Now you need the Expo notifications package installed because we will still use that. But now we will also need to do a couple of other things. For example, we will need to request permissions, at least for iOS, and we will need to get a so-called Expo push token, which will then act as the address to which we want to send a push notification, as you will see. So let's now go through these setup steps, and we find some helpful code snippets down there. These snippets actually even check for whether the app is running on an emulator or a real device, because now for push notifications, we will need a real device to test them. That's why we have this extra if check here to check whether the code is running on a real device or an emulator. And only if it's a real device, it will continue. I will not add this check, but you should be aware that you can only test this on real devices through Expo's Go app. Now it all starts with getting such a push token. And the push token is, in the end, simply a string that will be unique for every device. So every device will get its own unique push token, and therefore this push token will be the address which we will need later when we send push notifications to other devices. Because, of course, if you think about it, when it comes to delivering push notifications to other devices, you need some way of identifying devices. And the address of a device is simply such a push token, which will be unique for every device. Hence, in our code, we need to get such a push token, and it's up to you where you want to get that. You could maybe want to get that token only on a certain screen or after the user clicked a certain button. Here in this case, I will make sure that such a push token is fetched right when the app starts. So therefore, here, I will add another useEffect call in my app component and add my effect function and its dependencies. And now in this effect function, I want to get this push token. So for this, we again need to use this notifications package. And on this notifications object, we can call get expo push token async. This is the method we must call to get this push token for this device. And we will get an expo push token, which we can use with expo's push notification server to be precise, which is that server to which we can send requests to have push notifications delivered to multiple devices. So this server I mentioned on the slide before. Now this method here will return a promise which will eventually resolve to the push token for the device on which this app is running. And if the same app is running on multiple devices, every device will get its own unique push token, of course. And since this returns a promise, we can add then here or use async await to, well, get that data to which the promise resolved. So to get this push token. So here we will get our push token, and we can then, for example, log this push token here. We can console log this push token inside of this function, which will be executed once the promise resolved. To be precise, what we get here is the push token data, and in there we will have the push token, the actual token, in some nested field, as you will see. However, as we saw before in the official Expo docs, we won't be able to test this on our emulators because push notifications are not supported there. We will need to test it on our real device instead, and that is what we will do next. So we have our code for getting such a push token, and I mentioned in the last lecture that we won't be able to test this on the emulators, so we need to test it on our real device. However, before we do that, it's time to talk about permissions. Actually, for local notifications already, for iOS at least, we should have added some code that asks the user for permission if we also plan to ship this app without Expo Go. As long as we test everything here in Expo Go, everything will work because that Expo Go app already gathered all the required permissions for sending and using notifications. But of course, typically, as shown in the course section about publishing your app, typically you want to also publish your apps standalone and not just in this Expo Go shell. That's of course the goal, to have standalone apps. And once your app is a standalone app, it needs to ask for permission itself in order to tap into all these notification-related features. Therefore, as a next step, before we start testing this on a real device, even though we are using the Expo Go app here in this section for development, and we therefore wouldn't need to ask for permissions, we will ask for permission because I want to show you the code that you would write if you later also distribute your app as a standalone app. Now we can get those permissions with help of this notifications package again. And you also find this code here in the official docs, of course. There you can also learn how to ask for permissions and how to get permissions and so on. So what I'll do here is I'll add a little helper function, a function which I'll name setup push notifications or configure push notifications. And this is an async function, and that's why I'm creating a separate function, because we shouldn't add the async keyword in front of the effect function. That's not something you should do with useEffect. But here in configure push notifications, we can now use async await, and I will start by using the notifications package, and there we can call get permissions async. This is a method which returns a promise, which eventually will tell us what the current permission status of this app on this device is. So here we can await the result of that promise, and what we get back is an object which we can destructure with this syntax to pull out the status property. The status property will tell us whether we currently have permission to get such a push token and to get push notifications or not. Now I will add a helper variable, final status here, which I set equal to the status I got here. And then we can add a if check and check if final status is maybe not equal to granted, which means we don't have permission. Now, granted is one of the possible values that can be stored in status. So if this is not granted, then we know that we need to ask for permission. So therefore then, I will also use this notifications package and call the request permissions async method. So now that we know that we don't have permissions, I try to get them. Now this again yields a promise which we can await, and again we can use object destructuring to get the status that we have after requesting permissions. And now after requesting permissions, the user either granted the permissions or not. So we can then set the final status to this new status, which we got here. And then we can add another if check thereafter and check if the final status now is still not granted, even after asking for permissions. And if it's still not granted, then I want to use the alert API. So therefore I will import alert from React Native and call the alert method on it and say permission required as a title, and as a text we can then say push notifications need the appropriate permissions. And of course you can also set up a more meaningful text. And thereafter I will return to make sure that the rest of this function won't execute. If we make it past this second if check, we know that we do have permission to continue, so that we do have the appropriate permissions, and therefore it's there in this place where I then want to get this token. So I'll move this code for getting the token into this helper function, into this configure push notifications function, and I'll get the token after checking for permissions when I'm sure that we have sufficient permissions. Now, since this is now inside of the helper function, which uses async await, we can also change this code a little bit here and get our push token data with help of await and remove this then block and log this to the console after this line. So log our push token data here. Now with that, we just need to make sure that we also call this helper function here, configure push notifications. Therefore, still in this effect function, I will add this code to call this function. And now with that, if we save this, and I then reload this, on my iPhone, I don't get this warning anymore. I do get some warnings here in the terminal, because I'm still running the app on these emulators as well, and there it won't work. But on the iPhone, you can see that I'm not getting any warning anymore. I'm also not prompted for permissions here because I did actually grant permissions in the past already, so that might be different for you, but I'm not getting any warnings anymore. What you can also see is that above the warning in the terminal, I do indeed get some object here, and that's coming from running the app on an iPhone. And here, this object contains a data field which contains this Expo push token. This strange thing is this push token with that unique identifier for my device. So therefore now with that, we got this configured for iOS and we're requesting the right permissions so that we can then also get this push token. You also need to add some extra configuration for Android though. So I'll do this as well. And for that, I will first of all import the platform API from React Native, which you learned about earlier in the course already. And with that API, we can check whether we're running on Android or not. And after getting a push token, I will use this platform API to access the OS property and check if that's equal to Android. So if the app is running on an Android phone. And if that's the case, we should also use the notifications package and call the setNotificationChannelAsync method. This sets a so-called notification channel, which is required for Android to define on which channel notifications should be received there. And you can set this to default and then pass an object with more configuration options as a second argument. And there you should set a name property and set this to default as well. And add an importance property and set this equal to notifications dev.android importance dot, and then you can choose an importance, which will simply tell the Android device how important the push notifications received for this app are. And I will set that to default. And if you had an application which has high importance push notifications, you could set this to high. Of course, you should be careful with this setting though, so that you don't annoy your users by delivering them high priority push notifications all the time, whilst you might actually just be delivering some marketing notifications. So that is some additional setup which should be added for Android. And with that, we now got everything prepared to send and receive push notifications, and therefore the next step is to do just that. So let's now see how we can send push notifications. And before we add some code to send push notifications from inside this app, I want to show you a nice service provided by Expo, which you can use for testing push notifications. You also find this service in the official Expo docs and use this push notification tool provided by Expo, which you can also find by visiting expo.dev/notifications. And in this tool, you can enter such a push token, which we saw in the terminal a couple of seconds ago, and then also add a title, body, some extra data you might want to deliver, and some other settings to test sending push notifications to specific devices which have your app installed on them with help of this testing tool. So therefore, what I will do here is I will grab this push token for my device, for my real iPhone device here, and I will insert this here in this push token field, the full token, including this exponent push token part. We don't need the access token, but I'll add a title of test and a body of this is a test. I'll ignore all the other fields, and then I'll try to send a notification. So now here on my iPhone, let's see whether I get this notification when testing this. Here it is. This notification which appeared here is this push notification sent with help of this testing service provided by Expo. So that did work here. We did get this push notification, and this already shows us how we can configure our device for getting push notifications and how we can send such testing notifications. But of course, testing is nice. We might also want to send notifications from inside the device. We also might want to send notifications programmatically instead. And that's of course also possible. Now, when it comes to sending push notifications programmatically, my strong recommendation is to take a look at the official documentation, because as mentioned before, there you also learn how to do this from inside your backend code, which you might have. And very often it will be your backend code that decides that some push notification should be delivered to one or multiple devices. But since we don't have a backend here, and this is not a backend course, we will use a different approach, and we will send a HTTP request to this endpoint to trigger such a push notification. We could be doing this from inside some backend code as well, by the way. You can talk to this endpoint from any code base, from your frontend or your backend. But you can also do it from the frontend, which is very useful here. And therefore, what I'll do is back in app.js, in my app component, I'll add a new function, send push notification handler, and I'll connect this to a new button which I'm adding, which has a title of send push notification. And on this button, I'll add the onPress prop and trigger the send push notification handler function we just added. And in this function, I now wanna set up the code for sending that notification with help of that API endpoint I just showed you. Now for this, we need to send a HTTP request, and we can do this with the Axios library, which we used before in the course, or to mix things up, we can also do this with the built-in fetch function, which is built into React Native, or into JavaScript to be precise, and it's supported by React Native. This fetch function, despite its name, can not just be used for fetching data, but also for sending requests. And it wants a string that contains a URL to which a request should be sent. And in our case, that is this URL here, Expo's push service endpoint here. So we paste this in here. You can then also pass a second argument to the fetch function to configure this request. And we need to configure it here because we must set the request method to post. And we should also add a content type header, which we set to application JSON as a value. So therefore here, in this object, which we pass as a second argument to fetch, we can add the method property and set it to post, add the headers property, and add the content type header here and set it to a value of application JSON. And then we should also add a body property to define the actual request body. Now this request body must be in JSON format, so we can use the built-in JSON object to call the stringify method and convert a JavaScript object into a JSON string. So here I'm passing an object to stringify, and this object now supports a couple of properties, for example the to and the title and the body properties. Again, you can learn more about all the configuration options in the official docs if you want to dive really deeply into this, but title, body, and to are three essential properties which need to be set up to deliver your push notification to a certain device and set a certain title and message body. Now to should be such a push token. We'll set it in a second. Title can be test sent from a device, and body can be this is a test or anything like this. Now the push token, the address of the device to which we want to send the message, is typically something that would be stored in a database. So typically when getting that push token in the configuration function, once you got your push token data here, you would typically store the push token that belongs to a certain device and therefore to a certain user in a database. And then when you later decide that you need to send a notification to that device and to that user, you would get the token from the database so that you have the address you need to send the notification to. Here we don't have that because we don't have a backend, and I also don't want to start storing data on this device here. And therefore what I'll do is, for demo purposes, I will just grab this push token, copy it here, and actually paste this into my to field here. I will hard code it into this field. Again, this is just for demo purposes. In a real app, this would not be hard coded into the code, but it would be fetched dynamically, for example, from a database. Now with that though, we got this core setup which we need. We're sending this request whenever this function is executed. We don't need to do anything with the response from this request, although you could do this as well, because Expo's push service will actually give you a response, which you can use to get more details about the message that is scheduled now. But here, for the demo purposes, we don't need to do that. And therefore, I just need to save this. And with that saved, I got my iPhone up and running again, and I can now trigger this push notification from my Android device here. I can't receive push notifications here. I can still send a request to Expo's endpoint here to send a push notification to a different device. So triggering should work. And indeed, I accidentally clicked this button already. I received this message on my real iPhone. If I tap the button again, it arrives again. And every time I tap this button, I receive such a push notification on my iPhone. So this is working, and this is how you can send push notifications from one device to another programmatically with help of Expo's push service. So that's it for configuring and sending push notifications. I also want to highlight again that this code for handling notifications also executed on my real iPhone. It did execute there because notifications were received. And if I would have tapped those notifications, the other event handler, this response received listener also would have executed. So that's what I meant before. The code for handling those notifications didn't change, no matter if we're talking about local or push notifications. But you did now also learn how you can configure your apps for receiving push notifications and how you can send push notifications. Now, as mentioned, there's more you can set up and more you can do. The official docs are your friend to dive deeply into this. And of course, you can also send notifications from inside your backend code instead of your frontend code as we did it here. Both is possible. I also want to highlight again that you need to go through some extra configuration if you leave the Expo Go app. So if you build your app for production and for distribution through the app stores, no matter if you're using EAS, as we did in the section about publishing the app, or if you're building a standalone app without Expo at all. I mean, in that case, you can't use the Expo notification package like this anyways. But even if you are using the managed Expo workflow, if you're building the app for the app stores and you're not using Expo Go anymore, some extra setup will be required. And you can learn more about that in the official docs as well. This is really important, that you will need to go through some extra setup to configure your app, which you build with EAS build for push notifications when building for iOS or Android. The extra instructions can be found here in the official docs. And as mentioned before, in general, I recommend going through these official docs to learn all about push notifications. The extra setup isn't too difficult to set up though, and with that, you now know how you can send and handle notifications no matter if it's local or push notifications.
Congratulations! You did it, you completed this course, and this definitely was not a short course. But you now learned all the key features you must know about React Native to build mobile apps with React Native. And therefore, you're now ready to use that knowledge in your own projects, in real projects where you want to build real native mobile apps for iOS and Android with React Native. And I hope that you liked this course and got a lot out of it. I would definitely like to see you again in other courses, but either way, I wish you all the best for your future, and I'm happy that you were part of this course.
Welcome to this optional, that's important, optional module, where I want to introduce you to the JavaScript basics. And this module is really just a quick refresher. I do expect you to have some basic knowledge about how JavaScript works, what you use it for, and its base syntax. This module does not replace that. You can't really use that module with zero JavaScript knowledge, or at least it will be very, very challenging. But if you only got some very basic knowledge, or it's been quite some time since you worked with JavaScript, then this module will be a great refresher. Please skip this module if you already know JavaScript though, because then this module is not for you. So you don't have to be an expert to skip this. If you know JavaScript and you also know some of its next-gen features like the REST and spread operator or object destructuring, so a bunch of nice things that we can do in JavaScript, definitely skip this module and maybe come back later if there is some feature you don't recognize or you're not sure what it's all about. If you don't have that knowledge though, this module is for you. And also have a look at the next lecture where I provide links to helpful resources in case you're brand new to JavaScript, because there are some free resources that allow you to get started with JavaScript, after which you can come back to this module and to the rest of the course where you will need that basic knowledge. So now that we know for whom this module is, let me summarize JavaScript briefly. JavaScript is a weakly typed programming language. It's an object-oriented programming language, and it's very versatile. Now, what do I mean with that? Weakly typed means that we have no explicit type assignment. JavaScript knows types like numbers or text, which is called string, or booleans, which is true or false. but it doesn't force you to define which type you're using in a variable or in a function. And indeed, you can also have a variable where you store a number, which you then suddenly change to a text variable. So you can switch types dynamically. In other languages, this is differently, and whilst this gives you greater flexibility to be able to change it and to not have strict typing, it also can lead to errors. So it is just something you have to be aware of. Object-oriented simply means that data can be organized in logical objects, and we'll see these objects in this module. And one important concept here is that you have to be aware about the difference of primitive and reference types. And attached to this lecture, you'll find a link to an article and video I created for my free YouTube channel, Academind, where I do dive into primitive and reference types and where I do explain the difference and why they are important. So definitely check that out if primitive and reference types don't tell you anything. Regarding the versatility, well, we can see that in this course. JavaScript runs in the browser, and this is actually where it comes from. But you can also use it with Node.js to run it on your PC outside of a browser setup, or also on a server therefore. And that is exactly what we'll do in this course. We'll build a web server with Node.js, so we got this broad versatility of being able to use JavaScript on different platforms. And you can also perform a broad variety of tasks with JavaScript, also depending on the platform you're running on. You can, in the browser, listen to user events, re-render the DOM, and on the server or on a PC, you can work with files, with databases, a lot of cool stuff. So this is the summary of JavaScript and what makes up the language. Let's now dive into some core features, also some core next generation JavaScript features, which are supported by Node.js. And let's see some things we'll see throughout the course. For that, let's just play around with JavaScript. And I'm in a brand new empty folder, which I opened with my IDE, Visual Studio Code. And in there, I'll create a new file and I'll name it play.js. The name is totally up to you though. Now let me start with some core language features, variables and functions. And again, you should definitely dive into a core JavaScript resource like the ones I linked in the second lecture of this module if you are brand new to JavaScript. So I by now do expect you to know what variables, functions are. I also expect you to be aware of what if statements or loops are. These are all core things you gotta have set by now because they are crucial for JavaScript, no matter if you're using it in the browser or on the server. So for variables, you might know this syntax with the var keyword. You can have var name and, for example, store max in there, right? This would be a variable, and now you can use that, for example, to simply output it like this. And if we now run this file with Node.js by running node play.js, this is the command we have to write in a terminal, navigate it into that project folder, so into that folder where I'm having this play.js file, then I see max down there. Right? So that is some JavaScript code. We can also create another variable, age, which now would be a number. It's not enclosed in quotation marks. So this first one is a so-called string. This is a number. We can also add a third one, has hobbies, and that would now be a Boolean. These are some core types JavaScript knows. True, false are Booleans. Numbers are, well, numbers. They can also have decimal places. These are strings. And now here, I can also define a function with the function keyword, summarize user. This is how you create a function JavaScript. And there we could return something. Functions can return values with the return statement. They also can get input like user name, user age, and user has hobby. You can name these arguments as these things here are called, however you want. These are now local variables, only available inside of the function, not outside of it. And then you can return name is plus username plus, let's say, some text with a comma, a white space. Age is white space, user age plus, and the user has hobbies, and then user has hobby, something like that. Now here I'm simply returning some text which I'm manually concatenating by hard-coded strings and the dynamic values I'm getting as an argument. Now we can also console log the result of summarize user, and we call a function by adding parentheses after the name, and now we just have to pass in data we expect here as arguments. So we need to pass in 3 arguments here, the name, the age, and has hobbies, so the 3 variables I defined up here. We could have directly accessed them in the function too, by the way. We don't have to take the way of accepting arguments, but this is a purer function which does not depend on anything from outside the function, but gets all the data it works with as part of the arguments, which is a nice way of writing functions. And now, if I execute this, well, then we get this output here. Now, this is just a summary of the features you should be aware of, as I mentioned. I just want you to know, or I just want to be sure that you know how we work with variables, how we work with functions, how we call functions, and that you understand how parameters or arguments in the function are used in there and only in there. We couldn't use username outside of there because of something called scoping in JavaScript. We can then call a function like this and pass in the data. We could hard code the data here or refer to variables, which have to be available in the scope of this statement, which is the case for these variables since they are global variables. And these are variables and functions and how we interact, and these are some core features you have to be aware of. Let's now dive into something more exciting in the next lecture. Now that I had a quick look at the very basics and the core terms you have to know, let's dive into some next-gen JavaScript syntax you'll see throughout this module or throughout this course. Var is a keyword that creates a new variable, and actually it's a bit of an outdated syntax. From now on, we'll use let instead of var, and let also creates a variable. The scoping behaves a bit differently, but we can ignore that for now here. Check out some next-gen JavaScript resource like my ES6 course, or of course also some free resources to learn all about let. But the core reason for using let is that we now also have another way of creating a variable, and with that I mean a variable which never changes, which actually is the case for all 3 here. But let's say we actually do assign a new value to age here, but we never change name or has hobbies. We could absolutely use let, there is nothing strictly wrong with that, but to be clearer about our intentions in the code, and we know that we'll never change let name and has hobbies, we can also use a new keyword available in JavaScript, and that's the const keyword. This creates a so-called constant, and this makes clear that we never plan on changing the value of name or has hobbies. We do plan to change it of age, and that is why we have let. And that is the reason why we have 2 different keywords for creating variables, though again, these are not really variables, there are constants. Either const or let, depending on whether we plan to change this or not. So now if I execute this, it works in exactly the same way as before. But by the way, if I would try to set name to Maximilian here, and I do run node play.js again, I actually get an error now that I try to assign to a constant variable. So this actually already shows us the idea behind const, and you want to use const as often as possible to be as clear about what happens in your code as possible. And if something should never change, make it a const so that you get an error if you do accidentally change it. So here I'll revert this change, but I wanted to show you how let and const work. Let and const are 2 relatively new features in JavaScript. Another cool new feature are arrow functions. We can rewrite this function as an arrow function by, first of all, creating a new variable or constant. Since I'll never set a new value, I'll use a constant. And I'll give that the name of my function, so summarize user. The value which I then assign after the equal sign is a function. Now we could already have done it in the past with this syntax. This is another way of defining a function. The part on the right side is a so-called anonymous function, because we don't set up a name after function, but we make it a named function implicitly by storing the anonymous function in that named constant, so we can always call that constant, which holds a function, as a value, and we call the value with the syntax, and therefore this is like a named function here. So this would have worked in the past too. It is a way, or a different way, of defining a function, but we can now also use a new syntax where we remove the function keyword, and instead we add an arrow between the argument list and the curly braces. And this arrow is simply an equal sign and a greater than sign. This also creates a function. It's a bit shorter since we saved the function keyword, and it runs in the same way as this function ran before. Now, why would we use this syntax except for the reason that it's a bit shorter? Well, that is already a nice reason, but also there's one key difference regarding the this keyword which JavaScript knows. And attached you find a link to another video and article I created where I dive into the this keyword and how arrow functions help us with it. The attached article and video actually uses the browser, but it's the same for Node.js. So this will be helpful too. You have to know what JavaScript objects are for that, but again, that is some core knowledge I require you to have for this course. In this course, I will pretty much only use arrow functions. So this syntax for defining a function should be something you understand for this course. That this is the name of the function, and then here we have the arguments, and then we have the function body. Now a little side note. There is also a shorter syntax of writing this, or a couple of shorter syntaxes. Let's say I have another function, which I'll name add, and there I get two arguments, a and b, and I just return the sum of them, so the addition. Then you could write return a plus b, of course, and that allows us to run console log add with 1 plus 2, and if I now run node play.js, we see 3 here as a result. If you only have an arrow function with one statement, which happens to be the return statement, or which you are fine returning, well then, you can omit the curly braces, you can omit the return statement, and you have to omit it, and you just use the function like that. This simply is the same syntax as before with the curly braces and with return, and this function will now always return the result of this statement here. So now if I execute this again, we still see 3. Now if I would adjust this function to, let's say, always add 1, then I have just a as an argument, let's say, and I return a plus 1. Now I could call this by console logging add 1 to, let's say, 1 here. So the result should be 2. And I can, of course, execute this, and indeed I see 2 here. Now, in such a case, you already saw my auto formatting removed the parentheses I had there previously. Because if you only have one argument, and that's the case really for that case only, if you have one argument only, then you can just have the argument name here without parentheses, and it will work just as it will work with parentheses. So both works here, but you typically use the syntax without the parentheses. And again, my IDE auto formatting removed them for me. If you have an arrow function with no arguments at random, then you have to specify an empty pair of parentheses though. You can't have just a white space, you have to have that empty pair, and then you can have your code there, which obviously uses no arguments because that's exactly what I want to show here. So here I could have add random called like this without any data passed in, and now we see 3 here from that result. So these are arrow functions and their different syntaxes, and you will see them throughout the course, and you should recognize that syntax and understand how they work. Again, for a reason why to use them, check out the attached article plus video. Now let me get rid of that existing code. You find a snapshot of the code we wrote thus far attached to the last lecture. And let me write some new code. An important thing you work with, or important data structure you work with in JavaScript, are objects. You could have something like the person object, and you create an object typically with curly braces, and then in there you have key value pairs. You define the key by simply typing, well, whichever key you want to use. Let's say name. Then you have a colon, and you must have that colon. And after the colon, you have your value. In my case, a string max. And then with a comma, you can add another key value pair, age 29. Now, this is an object, and I can log person here. If I now execute play.js, we see that object being printed here. Now, objects allow us to group data together. You can also not just have variables in there, so to say, but you can also have functions in there. For example, a greet function, and there you can simply have an anonymous arrow function, or an arrow function in general, as a value after the colon. And then in there, you could have console log, hi, I am, and then the name, and this would now be accessed with the this keyword. Instead of an object, you have to use this to typically, and there is something special about this, which I showed in that video I linked before in an earlier lecture, but typically this refers to the surrounding object. And now we can use the dot notation, so dot, to access properties or methods, so variables or functions inside of that object. So we could now use this name. And now I can use that person and call greet with the dot notation and executing it as a function. So the dot notation is important on this, which refers to the object, or on you, referring to that object which is stored in this constant here. And now if I execute this again, I'm saying, hey, I'm undefined. Now why is that? Well, the reason for that indeed is what I taught you about arrow functions. This now, here, refers to the global scope, to the global node runtime scope, and not to this object. To have it refer to that, we either have to use the old school function, like this. Now if I repeat that, I'm saying, hey, I'm Max. Or we use a slightly different approach or syntax here in an object, and that is you don't use an arrow function, but you use greet like that. So you omit the colon, add the parentheses after the key name, and then without a function keyword or anything like that, you add your function body. And now this is a method of this object, and you see, hi, I'm Max2 now. So this is something important, and this is the syntax you'll see me use throughout this course, without the colon, parentheses right after the key, and then the function body. Besides objects, another crucial data structure in Node.js or in JavaScript in general are arrays, like hobbies. An array is defined with square brackets, and in an array you can have any data you could normally use too. You can use strings in there like sports and cooking. You can have numbers in there, and you don't have to use one and the same type in the array. Here we are mixing text and numbers. You could have arrays with just text, just numbers, and so on too, of course. You can use Boolean values, and you can even store objects in there or other arrays. That is all possible. Now here I'll have an array of text though, and you can use for loops to go through that. With this syntax, for example, with the for off loop, where we store each element for each iteration in that hobby variable. And now, if we do that, we would execute console log 2 times, because we have 2 elements and we're looping through all of them. And I'm outputting the current value we're currently looking at, because this will change for every iteration, going through it from left to right. We'll output that for every iteration. So now if I run this, we see sports and cooking printed in 2 lines, because this executes 2 times. So these are arrays. The for off loop is interesting. And it's also interesting that in JavaScript, we got a lot of built-in methods we can use on arrays. So on hobbies, on that array, if I add a dot, my IDE suggests a lot of methods I can use on arrays in JavaScript. And all these methods help me go through the elements in the array, manipulate them, get a subset of that array, whatever I need. Often you'll see map, for example, which allows you to transform an array or transform the values. And map will actually return a new array, so it will not edit the old one, but give you a new one. And we can print that new one here actually. And just to show that the old one was not edited, we can print that right below. And now map always takes a function where you define how to edit that array or how to edit the elements in the array. That function will be executed on every element in the array, one after another, and you return the updated version of the element. So here we would get our hobby. You can name this however you want. And here I'm using an arrow function with one argument only, hence no parentheses. And in here, I'll return the edited version. For example, here I could take my old hobby string and simply add hobby in a white space in front of that. So I'm simply constructing a new string which keeps the old hobby name, but adds hobby : white space in front of it. And yes, since we only got one statement in that arrow function with a return statement, we can get rid of the curly braces, get rid of return, and just return it like this. This would be the equivalent. And now if I clear this and I run play.js, I see the old array was not edited. That is my second output here. It's coming from this console log where I console log the original array. But the result of my map here is a new array where I have my edited items with hobby added in front of every item. And this is something you'll see me do quite a bit in this course. Use that map method. And as I mentioned, it's only one of the many methods provided here. Always check out the docs on MDN to learn more about all these methods. Link can be found attached to this video. And make sure that you understand how they work, or that when we use one of them in this course, you can quickly look that up in case it's not clear what exactly that does. Though, of course, I will do my best to explain it when we use it. But these are arrays, very important data structures, and some very important methods you can use on arrays. Now that we learned about objects and arrays, there's one common misconception I sometimes see in the Q&A section. Please check out that video I linked earlier in this article where I talk about primitive and reference types in JavaScript, because that is a crucial concept. Objects and arrays are so-called reference types, and you'll learn all about that and what that is in the linked video, so I'm not going to re-explain it here. They are reference types, and therefore when I store an array in a constant hobbies, I can still edit this array without violating the restriction that constants must not change. Let me prove that to you. If I comment that out, and I add a new line here, and I use another method, the push method, which allows me to add a new element to the existing array. So this will not return a new array, it will add it to the existing array. And here, I will add programming. Now if I now console log hobbies after pushing, and I run node play.js, you see that is the output. And we get no error about editing this constant. The reason for that is that reference types only store an address pointing at the place in memory where that array is stored. And that pointer, this address, has not changed by us adding a new element. So the thing stored in this constant is just this pointer, just this address, and this has not changed. Therefore, our constant value has not changed. The thing it's pointing at has changed, but that totally does not matter here. And this is something you have to understand so that you don't wonder what's going on when we do edit, in quotation marks, a constant value. We're not really editing the thing that is stored in a constant, we're only editing the thing that constant thing is pointing at. In modern JavaScript, there are two important operators you also should be aware of, since I'll be using them throughout the course as well. And that are the rest and spread operators. Now specifically the spread operator is one we'll use quite a bit. Let's say we want to implement a pattern where when we add a new hobby, we don't edit the original array, but we create a new array with all the old values and the new value. This is actually a pretty common pattern called immutability, where we never added existing values, but where we always replaced them with copies plus the changes. And that is also a pattern I'll use quite a lot in the course. The idea behind that is that we avoid errors because we always have this clear approach of copy, then edit, and don't edit existing objects, which might lead to more unreadable code. Now, to copy an array, let's say here I create the copied array, we got a couple of possible techniques. One of them is to use the slice operator. Now, if I output copied arrays down there and I run node play.js, I see sports and cooking, so I did indeed copy it. Slice simply copies an array. We can pass arguments to narrow down the range of elements we want to copy. With no arguments, we copy the entire array. Now, instead of slice, there's also a different technique. We can create a new array with square brackets, and we could add hobbies there, right? Now, what happens if we execute this? What will we see in the console? Well, if I hit enter, we see, well, it looks like a copy on first sight, but actually it's an array with another array in it. So the outer array has only one element, and that's the inner array. So it's not a copy, it's just a new array where the first element is the old array. And with that I mean the exact same object, not a copy of that. So we just created a nested array here. That, of course, was not what we did want to do here. And here we can use the spread operator. The spread operator are 3 dots we can add in front of an array or of an object. And these 3 dots are an operator just as the plus or the minus are. And they do one thing. They take the array or object after the operator and pull out all the elements or properties, so all the elements of an array or all the properties of an object, and put it to whatever is around that spread operator. In this case, we got square brackets around the spread operator, and therefore all the elements which are pulled out of the existing array are added to the new array. And therefore, if I now run this file again, whoops, and I save it before running it again, now we see this was the output of the old approach, the nested array. Now we got no nested array anymore. We got one array, and this is now a copy of the old one because we take the spread operator to pull out these elements and add them one by one to the new array. So this is something you'll see me do a lot to copy existing arrays or objects. There it would work in the same way. We could have our copied person by using curly braces, then the spread operator, the 3 dots, and then the old person. And now if I console log the copied person here, and I execute this file again, this is our copied person here because I'm pulling out all these elements from that object and I add it to a new object. So this works for both objects and arrays, and it is syntax I'll use quite a bit in this course. Now this is the spread operator. I also mentioned the rest operator. And the rest operator is essentially the opposite. Let's say I have a function which I'll name toArray. It's an arrow function. And there I expect arguments arg1, arg2, arg3. I want to return an array that contains these arguments. Whoops, and I should add an equal sign here. So I want to return an array that contains these arguments. I can return square brackets here, of course. And then the first element will be arg1. Then I have arg2 as the second element and arg3 as the third element. Now I can console log toArray, and I pass 1, 2, and 3 as the 3 arguments to that function. If I now execute play.js, we see an array with 1, 2, and 3, these 3 elements. So this is working. But this is totally not flexible. What if we want to pass 4 arguments? Well, we could call it like that. JavaScript actually allows that, but of course it doesn't get added because we only work with 3 arguments here. What we could do is we could use the so-called rest operator there, ... and then just args. And this will actually take all the arguments, how many we might specify, that doesn't matter, and it will bundle them up in an array for us. So here, args will be an array, and I can just return that actually. And now if I re-execute this with toArray getting 4 arguments, you see now I have my array with 4 arguments here. So the rest operator looks just like the spread operator, 3 dots, and it's the place where you use it that defines how you call it. Are you using it to pull elements or properties out of arrays or objects? Then it would be the spread operator. Are you using it to merge multiple arguments into an array, and you use it in the argument list of a function? Then it's the rest operator. It's the same operator by the syntax, or from a syntax perspective, the name differs depending on the place where you use it. I'll not use that syntax a lot in this course, but it's still nice to know. But being able to pull out elements or properties, that is something you should understand, because that is a syntax you'll see me use quite a bit throughout the course. Rest and spread are important syntaxes to know. Now I want to dive into another important feature, and that is destructuring. Now let me comment out this code down there, and let's begin with object destructuring. I got my person object, and now let's say we have some code where I only need the name. So I have a new function, print name, let's say, and that actually takes the full person object, because for whatever reason we wrote it like this, or we simply have a function where we are able to get multiple arguments or a full object because some third-party package always gives us that person. We can't change that. So we get the person here, and I only want to console log person.name. Now that is totally fine of doing it like this. I can now execute print name here. Now I need to pass person here. Now to avoid naming confusion, you can name this here however you want. So here we could name it person data, and inside here we use person data, so that function does not use that person, it just expects any person data. We then call that function and pass in that person as an argument. And now if I execute that file, I see Max here. This is stemming from this line here. Now of course we can absolutely do it like that. And we always get person data because, again, let's say this is a function which is actually called by some third-party package, which is a pattern you see quite a bit throughout this course. Now, therefore, we can't change the data we get. But in this function here, we are only interested in the name. We can then use a syntax or a feature called object destructuring, where we add curly braces here in the argument list. And we then specify the property of the incoming object we are interested in, name. That is this property we have here. Then this will be pulled out of the incoming object. The other properties will be dropped for this function, and it will be stored in a variable named name, which we then can use in there. So now if I execute this again, I also see Max. But now we're using this destructuring syntax. And we can pull out the age too if you wanted to, or the greet function. So that all works, and that is just a syntax we can use that allows us to write a bit of a more understandable code where we are very clear about what we need from the incoming object, and which then gets stored in a local variable that we can just use in this function. And you can, of course, not just use destructuring inside of a function. You can also use it outside of there. You can create a new constant here, for example, and then the syntax will look like this. Curly braces equals person. Curly braces on the left side of the equal sign are something we don't see that often in JavaScript because typically it's wrong, but for destructuring it's correct. And then here we can have the name and the age, and this will create 2 new constants which hold the values stored in name and age. So these names here have to match the property names of the person. And now we can console log name and age like this. If I now re-execute that file, this output here is coming from this console log, and the values we're outputting here are retrieved via object destructuring. Now there's also not just object destructuring, you can also destructure arrays. So if we go back to the hobbies, which we have here, well then if we would want to destructure that, we can also create a const. You could also use let, by the way, the same for the object destructuring if you plan on changing it. You could use a const for hobby1 and hobby2 wrapped in square brackets, and then assign this to hobbies. And now if you console log hobby1 and you console log hobby2 and you execute that file again, you see the two hobbies being printed there. Please note there are no square brackets around them in the console log because we're not logging an array here. We are logging two individual values which we got via array destructuring. Unlike the object destructuring, here you can choose any names you want because in arrays your elements have no names. They are instead pulled out by position. So this will always be the first element, this will be the second element. In objects, you pull them out by name, by property name. So that is destructuring, and this is also something used in this course. It simply allows us to access elements in objects or arrays quickly by their name or position and to drop, and that does not mean delete, they're not getting deleted, they're just not used in our function or whatever we're writing. So to drop the data we don't need in that specific code snippet we're working on. Now, I cleared the play.js file again because to conclude this quick refresher module, I'll dive into another core concept, and that is how to work with asynchronous code. And for that, we first of all have to understand what asynchronous code is. Let's say I set a timer with setTimeout, which is a function built into Node.js. There, we define a function that should execute after a certain timer expired. Here I'll use an arrow function, you could use a named function, whatever you like. The second argument is the timer, let's say 2 seconds. You express it in milliseconds, so 2 seconds are 2000 milliseconds. In there, I'll simply log timer is done. If I now run this file, for 2 seconds nothing happens, and then we see timer is done. Now this is asynchronous code because it doesn't finish immediately. And it would even be async code if we had 1 milliseconds there. So if it's super fast, it does not happen immediately. In other code snippets, like if we have console log hello and console log hi, these two snippets are synchronous code because they are executed right after each other. And yeah, technically, of course, Node will take some time to execute them, but there is no delay other than your hardware, so to say. And therefore, this is synchronous code, this is async code. Asynchronous because it does not execute or finish immediately, it takes a little time, even if that's super short. And indeed, if I execute this file like this, you see hello and hi before you see timer is done, even though it's super fast. Because Node.js and JavaScript in general does not block your code execution until that is done. Indeed, here, it will recognize this so-called callback function. So a function should execute in the future. It should call back later once it is done. So once this timer expired here. It will just recognize that and will then immediately move on to the next line and will execute all the synchronous code and then execute your async code once this is done, which is why we see hello and hi first, even though in our code, timer is done is printed first. And that is a crucial concept you have to understand in JavaScript and especially in Node, and I will come back to that throughout the course because it's so important. Now, when working with that, and I'll increase this to 2 seconds again to make it even clearer. Then you will see, again, our sync code runs, and then after 2 seconds, this code runs. When working with async code, we get multiple techniques of, handling it. The callback function is one, the oldest one, and you'll see it quite a bit, especially in Node.js. There's nothing wrong with it, but you'll face a problem if you have a couple of depending async operations. So here we set the timer, and now let's say I create another function which I'll name fetch data. And in there, I will also just set a timer because I don't want to set up some database or something like that where we fetch data from. We'll do all that throughout the course. Of course, no worries. So here again, I have another timer in there, which takes like 1.5 seconds. And now here in fetch data, I need some way of, doing something when this inner timer is done. So here I will actually expect an argument, which I'll name callback, because this argument will be a function I will eventually call in my inner function here once I'm done with the timer. And there I can pass done as a value. Now in the place where I use fetch data, let's say that's inside of this set timeout call, I call fetch data like this. There I now need to pass another callback. And here I will get the text passed by the callback in my function when I execute it. So I will get some text here, and I can console log that text. Now this might look confusing. In the end here I'm creating my own function which gets a callback so that I can define a function which should execute once this inner timer is done from some other place. So from this place here, this is the function which effectively is passed in as the callback, and I'm executing that function here. Now if I save that and I run that, takes 2 seconds, then the timer is done, and then after 1.5 seconds I see done. Now if we have a couple of nested async calls as we have here, we go deeper and deeper from a callback perspective. And that is why we also have a feature called promises, which we can use in Node.js. Now often we'll use third-party packages that already use promises for us. So the syntax I'll show you now is one you rarely have to write on your own. That will be done by the packages behind the scenes. Still nice to know. You create a promise inside of our fetch data function here, let's say, by storing it in a constant or variable, and then by using the new keyword, which you use in JavaScript to create a new object based on a constructor. If constructor functions are something that tells you nothing, check out some basic introduction resource to JavaScript, because constructor functions are a core feature in JavaScript. And here you use the promise constructor function, which is built into JavaScript and Node.js. And this actually also takes a callback, which gets 2 arguments, resolve and reject. You could name them however you want, but these are 2 functions. And the first one completes the promise successfully. It resolves it successfully. The second one rejects it, which is like throwing an error. You then take your async code and move it into there. And again, you rarely have to write this on your own. Most packages already do that for you and give you the finished promise, which does all the magic behind the scenes, hidden away from you. Here we do it manually. So now in that callback, we have our own function. Set timeout does not give us a promise API, unfortunately. So here we also have to use a callback. But in there, we now no longer use any callback function we get. I get no argument here in fetch data anymore. Instead here, I resolve done, let's say. So I successfully return the resolve value. Now in fetch data, after defining the promise, we just have to return it. And please note, this is synchronous code. So actually, this will be returned immediately after the promise gets created, before the code in the promise is run, which will happen sometime later when we actually call that function and when this timer then completes. So we now return that promise here. And in the place where we call fetch data, we now no longer pass a callback, but we can now use then, which is callable on a promise, and we return a promise. And this simply allows us to now define the callback function here, which will execute once the promise is resolved. Now, what is the advantage of that? If we had multiple such promises, so let's say I call fetch data again in there, then I don't have to use then like this, and therefore I would end up with nested callbacks again. But instead, inside of a promise, and the then block is part of a promise, I can just return a new promise and then add the next then block after the previous one. Like this. So now we have a chain of then blocks. This one gets called on the first promise. Then in the then block, I return another promise. And even if that would not give us a promise, inside of a then block, returning it would convert it to a promise that instantly resolves. And then we add another then block, which is now referring to this promise here. And this is more readable than having infinitely nested callbacks. So now if I run that, we see hello, hi, the timer is done, we see done, and we see done again because I'm calling fetch data twice. So this might be difficult to wrap your head around for the first time. We will reuse it throughout this course and then it will become clearer. Again, this code is mostly not written by you, but it is a crucial concept that makes our async code more manageable. There also is another way of managing this, async await, 2 special keywords you can use in modern JavaScript, and I'll have a separate section about this towards the end of the course. I don't want to introduce it here because it can actually be more confusing than this syntax here, and I want to stick to this one to not introduce too many new features at the same time here. Async code is something you have to understand though, and if it's not totally clear by now, that is fine though. You will see it throughout the course a bunch because we have a lot of asynchronous events in Node.js, and I will explain this multiple times. I'll also explain promises again. I just want to ensure that you have seen this by now and that you then have a chance of understanding this, how it works, and how we deal with it. That's it for this refresher module. Obviously, this is no complete JavaScript module. There are way more features which I didn't touch on, and the reason for that is simple. I do require very basic JavaScript knowledge at least. If you got none, check out the resources I linked in the second lecture of this module. These resources allow you to dive into JavaScript for free or with paid courses, whatever you want. And with that, plus this refresher about next-gen JavaScript items or features as well, you are more than prepared to continue with the course and now understand the code we will write throughout the course. I hope this was helpful. Let's now dive into Node.js and write exciting applications. To ensure that we're all on the same page and we all have the basics of React down, let's now have a brief refresher on React.js, understand what it is all about, how React generally works, and how you build modern front-end web applications with React. Now, one important note, though, this does not replace a complete React course. It's only a brief refresher having a look at some of the core fundamentals that make up React. I definitely recommend that you also have a look at a dedicated React course, like my React the Complete Guide course, if you want to learn all about React and if you want to ensure that you get the most out of this course as well. We're just having a brief refresher here. Now, in detail in this module, we'll have a look at the React.js basics and understand how React works there and how we can build web applications with React. We'll also have a look at how React manages state and stays reactive and what makes up React in the end. And with that, let's dive right in. So, what exactly is React.js? It's a JavaScript library for building user interfaces. And as such, it's all about running JavaScript in the browser. It's a JavaScript library for browser-side JavaScript code. It's not a Node.js library. It's a browser-side JavaScript library. Now, to be precise, React.js itself is referred to as a library because it's very focused on that user interface thing. But it actually started a huge ecosystem with other third-party packages that, for example, help us with app-wide state management or with routing, front-end routing, and therefore effectively you could also call it a framework, I would argue. But these are semantics, not too important right now. Let's instead understand how React works and how we use it. React helps us build user interfaces that are shown in the browser, that run in the browser, and therefore we use it to build the front end of web applications, what the user sees. React does not run on a server. React does not communicate with databases. We use it to build highly reactive modern user interfaces. And we do so by following a declarative approach, which means that in React we rather define the result and maybe different states of the result and under which state we want to render what and want to show what on the screen instead of the steps that lead to the result. That would be an imperative approach, which is basically what we have if we use vanilla JavaScript, where we have to define every step, add this element, add this CSS class to an element, remove this element. This is what we do in vanilla JavaScript. And this can be very cumbersome in very complex user interfaces. We typically don't want to do that if we're building bigger applications, because managing and orchestrating all these steps and ensuring that when something changes, we execute the right steps is very error prone and takes a lot of effort and work away from our actual business logic and from building nice user interfaces, and instead forces us to spend a lot of work on JavaScript primitives, on reinventing the wheel, and so on, and we don't want to do that. So in React.js, we instead focus on the result, and we do so by using components. Components is a concept introduced by React. Basically, these are UI building blocks, which we define, and you will learn how you do that in this module, of course, which we define, and then we compose our user interface from these components, and every component can also define what it should render under which circumstance, and React will then magically wire up everything behind the scenes and implement all these steps in the gray box here for us, so that we don't have to write the steps, we just define the results. This is React.js in a nutshell. Now let's have a look at how it actually works when we write some code. For this, attached you find a starting project. This starting project was created with Create React App, a tool created by the React team in the end, which makes it easy to spin up new React projects and give us a project structure like this. I adjusted it a little bit, but generally it's exactly the same you would get from this tool. Now, why do we need such a tool? Why don't we just import a script in a HTML file and get started? Because React is a bit more complex than vanilla JavaScript. In the end, we ship vanilla JavaScript code, but the way we write the code is a bit more convenient to us as a developer. We can use certain features which wouldn't run in the browser, and therefore this project setup here has a couple of tools included which take the code we write as a developer and actually convert it to code that runs in the browser, so that we have normal code that is executed in the browser, but we have an easier time writing that code as a developer. In addition, we get a development server, which is a simple server that serves our front-end application, so which has no backend, only serves that front-end application, and which automatically reloads or injects changes whenever we change and save something in one of our source code files. In addition, here with React, we're building a single-page application. That's not a must-do, but it's a common choice. In a single-page application, you only have one HTML file, which in the end is returned by the server serving that application, in this case, this HTML file, which itself is relatively empty. But this file will then later include script imports. They will be added automatically by these tools I mentioned earlier, which in the end host and run our React application, which we in turn write here in the source folder with our files we got there. So that in the end, we have a web application, a front end, which consists of one HTML file, where then JavaScript is used to render something on the screen and re-render that something on the screen when it's needed. And that allows us to build highly reactive modern user interfaces where everything happens instantly. Because JavaScript runs in the browser, things happen instantly. We don't need to wait for a new HTML file to be downloaded from a server. Instead, everything is already there. So when a user clicks a button and we want to show a box on the screen in response to that click, boom, it happens instantly because of JavaScript. That's the feeling we want to provide, and we can do that with React. Now, enough talking about the theory, let's write some code. As I mentioned, we do that here in the source folder, where we find an index.js file and an app.js file. Both very simple files. Now, let's have a look at the index.js file. There you see we have a couple of imports at the top. This is, by the way, how you import code on the front end. Import something from, and then either a relative path to your own file, or if it's a third-party package, just the package name. And then here we have imports from our own files with a relative path, as I mentioned. And then here we are executing one command in the end, React DOM render. Now this is coming from the React DOM object here in the end, which we're importing from the React DOM library. And that renders this strange thing, which is not regular JavaScript, into this place on our HTML page. This is regular JavaScript, and here we are selecting the element with an ID of root. If we have a look at our single HTML file, that is this div here. So that is in the end where our React single page application will be hosted to, and thereafter React will take over and render everything in that place. So that is what we're doing here, but what is this strange thing? Now for that we need to understand what components are and how React works. So we learned that we have this index.js file, and I can tell you that this file in the end includes the code which executes first when we start our app, and that this renders this strange thing into the place of this div here. Now what is that strange app thing here? We're importing app from this app file, in the end from the app.js file, because extensions are added automatically on the imports. And there what we have is in the end a JavaScript function. This is a regular function, an arrow function stored in this constant, and then we export this constant and therefore this function. Pretty straightforward. But the thing inside of the function is not straightforward. What we return here looks like HTML, just like this looks like HTML. But it's in a JavaScript file. It can't be HTML, right? You can't add HTML in a JavaScript file. That's a special syntax invented by the React team. It's called JSX, and it allows us HTML-looking code in JavaScript files. And under the hood, this will be translated to instructions React understands. In detail, this here is similar to React create element, a method provided on this React object here, and then here h1, and then here null or an empty object, and then as a third argument your text here. For example, hi, this is React. Different text than before, but it will render something similar on the screen. This will yield the same result, and I can prove that to you if we simply start our development server and try to see this app in action. To start it in the package.json file, we find a script, the start script, which already exists there. And this will in the end use that tooling I mentioned earlier to then transform our code and to start up a development server, which automatically reloads or injects changes when we change something. So here we can open up a new terminal integrated into this IDE, and there run npm start to bring up that development server. And you should keep that server up and running as long as you are working on your code, because when you close it, you can't preview your page anymore, your app anymore. Now when you start this server, when you run npm start, it should automatically open up a new tab in the browser on localhost 3000. If it doesn't, simply do so on your own and visit it. And there you should see, hi, this is React, which clearly is the text I entered here. So in the end, this here is React syntax, and we could write our entire app with this syntax. But this gets very cumbersome, especially if we start nesting elements into each other. That is why React gives us this alternative JSX syntax, which in the end is just translated to React create element and then what I just showed you. That's also why we need to import React here even though it looks like we're not using this React object anywhere in this file, right? We have this React text here, but that's something different. So we're not using it anywhere in this file. Well, it gets used implicitly because this is just syntactic sugar in the end. It is translated to that other syntax I showed you. And that is what React is all about. We tell React which elements it should render. And under the hood, it then will translate this into commands that the DOM understands, that the browser understands to render real DOM elements. Now, for example, if I add the title here, which gives us this tooltip that's built into the browser basically, this works. And I save this, it automatically reloads. You don't need to do so on your own. And if you now hover over this, you see this tooltip. This works. Very small here, but you can see it if you test this on your own system. Now, this works because that in the end is translated to React create element h1, then this object which we previously left empty. Here we set the attributes or the properties we want to set on that DOM node which is created here. In this case, title to this works. And then thereafter we have the text. This is how this works, and React will do everything it needs to do. It will create this element, it will set all these properties or attributes here, and it will render the last argument here inside of that created element. And that's also the part where this JSX code helps us, because if in here we have, let's say, another HTML element, we would have to nest multiple React create element calls into each other, which quickly becomes very hard to manage. That's why this JSX syntax here is a great idea, a great invention. So we will use this syntax, and we also use it here in index.js. The difference is, though, that here we don't use it with a normal HTML DOM element, but instead here we use a custom function, because we are using what gets exported in the app.js file. And what we export there is a normal JavaScript function. Well, that is one of the most important concepts of React: components. React is all about components. Now, what does this mean? This function here is of course a regular JavaScript function, but it's also a React component. What makes up a React component? A React component can be one of two things. It can be a function which returns JSX or returns React create element calls, or it can be a JavaScript class that has a render method. So this here, if I change this, would also be a React component. Class app extends React.component. That's important. You have to extend React component. And then you have to add a render method. And in that render method, you return JSX. This is a regular React component as well. And if I save this, you therefore see the same output as before. It works in basically the same way. There are some technical differences, which I discuss in detail in my React Complete Guide course. Here, it doesn't really matter. In modern React, you can use functional components only, so function-based components, and that's therefore what we'll do in this course. We'll write every component as a function. It's not a must-do, and as I mentioned in my React Complete Guide, you learn about both types and how they differ. But using function components only definitely is a modern way of using React, and it is therefore the way we will use. But always keep in mind that this is just a regular JavaScript function. What makes it a React component is that it returns this JSX or this React create element logic in the end here. If we return, let's say, an object instead, this would not be a React component, and hence you get an error if you save this. It really has to be JSX code, something which can be interpreted as JSX, like this here. This is how React works. And therefore here I am exporting my own component, because this is treated as a component, and your own components can be used in JSX as well. The only important thing there is that they should start with a capital character in the file where you use them in JSX, because this tells React that it's not a built-in HTML tag. App wouldn't be a built-in tag, but that it's a custom component. And this information is important to React, and therefore start with an uppercase character, but then you can use any custom component in JSX. And the cool thing now is that we can build up our application from small reusable components and compose our user interface with the help of such components. And with that, why don't we do that? Why don't we build a simple first React application and see how things work together there? Now, in this refresher course module here, we'll not write a complex React app because that's simply not the idea of this module. We will write a realistic app in the main module later in this course, after this module here, where we will work on the course project. So that's just a refresher here, and I focus on the core React elements therefore, and not on building an amazing application. So React is all about components, and therefore typically we split our app in components. Now let's start without splitting it though, and instead of outputting a h1 tag, here in app, I will use a div, let's say, and in that div, let's add more HTML code. I'm saying HTML here. Of course, it's JSX, but it is translated to HTML, to DOM nodes in the end, right? But it is JSX. So here we could have a h2 tag where we say course goals, and below that we want to have a list on, or the list of our course goals. And there a goal could be that we want to finish the course, that we want to learn all about the course main topic, and that we want to, let's say, help our students in the course Q&A section. And that could be some goals. Now, a very trivial application. Now, I don't have any special spectacular styling here, which is why we save that and we get this output. Now, I will add some styling, and for that, I will add a app CSS file here and import that file into the JavaScript file. This, of course, is not possible in vanilla JavaScript, but because of that under the hood tooling, which in the end analyzes our files and then transforms the code, this is possible, and this is simply transformed to inject this CSS code into the HTML file as well. Now here, I'll give this a CSS class, and there is one special thing. The class attribute like this doesn't exist in JSX because class is a keyword in JavaScript, so it is class name, and this is how you add CSS classes to elements in JSX. This also, of course, is kind of a proof or reminds you of the fact that this is not HTML, but HTML-ish looking syntax. I'll name this class goal list here, and now in here we can define some styles for the goal list here, and I will simply set list style to none here, remove a margin or give it a margin of 2 rem top and bottom, and a padding of 0. And on every goal list item, I will add a margin of 1 rem top and bottom, 0 to left and right, and then simply a border of 1 pixel solid, and then this grayish color here, and a padding of 1 rem. And this is very, very simple styling because I don't want to spend a lot of time on writing CSS styles here. Now, maybe one adjustment. Let's actually give the list a margin of 2 rem in all directions. Now we have this list of our goals. To adjust the course goals here at the top, I will also give this div a class name of course goals. And then in the CSS file, maybe at the very top, we can style course goals, and there the h2 tag to be aligned in the center, just like that. Now, again, very huge goals, but that is okay for this course here. We're just practicing React. So we got these course goals here. Awesome. This, of course, is a very simple markup. Now, what you often would do in React is you would split this into more components. You would, for example, outsource this list into a separate component to keep every component on its own, relatively lean and focused on one task. For that, we can add a components subfolder here in the source folder. And in there, I will add a goal list.js file. This will hold my goal list component. Now, to create such a new component, we first of all have to import React from React. Otherwise, we can't use this JSX syntax. And then I mentioned that a component is a function. And by the way, you can also create it with the function keyword or with the function expression or with the arrow function syntax I used before, which is the syntax I will use here, but that is not a must do. And then here I export my goal list like this. And now in here, I return this unordered list. So I'll cut it here and then add it here as a return value. And if I reformat that, you see automatically these parentheses are added around it so that this can be nicely formatted across multiple lines. Otherwise, this would not be valid JavaScript. So it is. With the parentheses it is, because then JavaScript knows that this block belongs together. So now we have the goal list in here, and in app.js, we can now import our goal list component. You can name this here however you want. Doesn't have to be the same name as under which you exported here. Only important thing is that it has to start with an uppercase character here in app.js. And I import from the components folder and there from goal list. And as I mentioned earlier, you can omit the file extension here. It's not required. And then here you use goal list like a regular JSX element, like a regular HTML element, you could say. But since we have no content between the opening and closing tag, we can and we have to write a self-closing tag here. This would not be allowed. You always have to close tags in JSX. So this would now be my goal list component. And therefore, if we save this, we see the same output as before. We also get the same styling because styles here are always applied globally, even if you import them into a specific component file. And still, it is a good practice to set up the styles in the CSS file next to the component they belong to. Hence, I will add a goal list CSS file, add my goal list styles there, and import that goal list CSS file into the goal list JavaScript file. This is not a must-do, but it makes it easy to find the styles that belong to this component. Keep in mind that styles are not automatically scoped to a component though. The normal CSS rules are applied because all the CSS files, no matter where you import them, are applied globally to your entire page. With that though, we're back to the same result as before. So why did we do that then? Why do we split this up if we have the same result as before? I created the separate component, A, of course, to practice creating your own components, but B also because it really is the core philosophy of React to split your app into smaller pieces. Of course, it's up to you how small you want to split it. Every list item, for example, could also be its own component, and there would be nothing wrong with that. The idea simply is to have small, manageable code files, and later, once we add more logic to the app so that we can also interact with it and we change the number of goals, for example, upon a button click and so on, we of course want to be able to manage a lot of the logic in the goal list component and not in other components. So really splitting it into components has the idea of separating concerns, of keeping your files small, focused, and manageable, which if you're working in bigger projects, is a huge win because it makes it much easier to manage and work in such bigger projects. Now, thus far, everything in our app is hard-coded though. Now, more realistic would be that, let's say, our goal list is managed here in app.js as data, and we want to render the goal list HTML items or JSX items based on that data. Now I'll manage it here in app.js simply because later I will add another component here that helps us create new goals. But for now, let's just add a normal constant here to this functional component because it is a normal JavaScript function. Of course, you can do more than just return JSX. And this constant here will have my course goals. You can name it however you want. And this will be an array. And in this array, each goal can be a JavaScript object created here with the object literal notation. Of course, you could also create your own class or constructor function and instantiate that to create such an object. Now let's say every goal has an ID, CG1 for course goal 1, and then has some text, let's say. And the text here is simply the text I have hard-coded here. Finish the course. So I'll copy that and add this here. And I'll split this across multiple lines to make it easier to read. Because I'll not just have one goal, but 3. So the IDs are CG2 and CG3, let's say. And now I will just copy all that text here into my objects here in app.js. Also that last text like this. And there I can now also get rid of that ampersand thing here. We don't need it here. We can output the text like this, and React will render it properly. So now we have the course goals array, and my idea now is that in the goal list component, these goals, that data here, should in the end be output. So it should be output dynamically in this component, in the goal list component, instead of being hard-coded. So we can remove this code here. Now that leaves us with two problems. Number one, how can we output a list of data dynamically in JSX? But more important than that at the moment, how can we get that list of data, which is defined in the app component, into the goal list component? Well, let's focus on that first, because without that, we can't focus on the other problem. We can pass data from component to component with a concept called props, short for properties. We can define our own, you could say, attributes, which are these props, on our own components. So for example, here on goal list, we could say we have an items attribute or a goals attribute, totally up to you. I'll go with goals here. And that goals attribute, or prop is the common term, so this goals prop, then passes data to that component. Now for that, I don't use a string here, which I want to pass down, but instead I want to pass down my JavaScript data structure, the array here. And for that, here actually we use another special syntax in JSX. We use single opening and closing curly braces. Looks like we're creating a JavaScript object here, but we are not. If you do this inside of JSX, which I am doing here, that's JSX, then this means you wanna merge your JSX code with some JavaScript expression in the end. And here we can point at course goals. That is a valid JavaScript expression. We're just pointing at a constant. And what this in the end means is that React will pass course goals here, the value stored in this constant, in this case this array, into this place of JSX. In this case, into this prop, therefore. So goals will be a prop that holds a reference to this array now. Now inside of goal list, we can now receive that goals prop. So let's go to goal list and see how that works. In goal list, we have a function, right? A functional component. Now this function right now doesn't get any parameters. We can change this. We can receive a props parameter here. Every function that is used as a React component, which means it returns JSX, also receives props. This is an object passed to your React functional component automatically by React. And it's an object that bundles all the props you passed to the component. So in our case, goals is the single prop we have. So here we will have an object which has a property with the name of goals that holds the value passed to that prop. So in other words, here I could console log props.goals. .goals because I named my prop goals here. If you chose a different name here, which is perfectly fine, you have to use the different name here. Now if we save that, we won't see our goals anymore at the moment. But if we open the developer tools, we see the array being logged here, and that log is coming from goal list line 6, as you see, which of course is this log here. And there we see our goals data, which means, yes, it arrives successfully inside of the goal list component. The concept of props is a super important concept in React because this is what allows you to pass data from component A, the app component, to component B, the goal list component in this case. Now let's have a look at how we can output a list of data dynamically in JSX, because here we got a list of goals, an array of goals, and we want to output this as list items here in our unordered list. How can we output an array of data as JSX elements? Well, actually, it's relatively trivial. We will map this array of JavaScript objects to an array of JSX elements because React is capable of outputting an array of JavaScript elements. For that, let me show you how this works. Let's use these single curly braces because I want to add a JavaScript expression here. And my expression here is a simple array, but an array of list items. Hi, and then another one. This works. I output this in my JSX code with the single curly braces because this here, of course, is not JSX, it's an array, but it's an array full of JSX. And if I save this, it outputs high and this works. We get an error or a warning, which you can ignore for now, but this works in general. Now, since this works with hard-coded data, we can also output our array of goals. So we can output props goals here. But the problem is that props goals is in the end an array of JavaScript objects, not an array of JSX code. So if we try to output this here, it will fail. It tells you that objects are not valid as React child or as React children. So in the end, we can't output plain vanilla JavaScript objects in JSX. Instead, we need to map every object into a JSX equivalent, so into a renderable element. So here we want to map every object into a list item in the end. So on props goals, which is an array, we can call the map method. That's a default vanilla JavaScript method that exists on any array. The map method takes a function, here I'll pass in an arrow function, which is executed on every element of the array you call map on, and then this function here will return a transformed version of that element in the original array, and overall map will then return a new array full of these transformed data pieces. So this function will therefore receive the existing element here, so every goal in our goals array, and then returns a new element. So in this new array returned by map, I want to have a bunch of JSX elements. So here I will just return a list item, which is JSX, of course. And in the list item, I want to output my goal text. Now, goal here is that JavaScript object we have in the original array, because this function runs on every element in the original array and gives you the object in the original array, or the data piece in the original array, as an argument. So goal here is that object which looks like this here. So I'm only interested in the text here, and again, we can output the text by outputting a JavaScript expression here, hence we need the curly braces in our JSX code here, and we have goal.text here. My expression is that I access the text property on the goal object. So now what happens here is I map my array of plain JavaScript objects to an array of JSX elements, and such an array of JSX elements is renderable, as you learned. So now if I save this, you see this outputs my course goals again. Now we also get a warning regarding a unique key that is related to how React re-renders the DOM, and that it wants to do this efficiently. You learn more about that in my React the Complete Guide course. And therefore, whenever you output lists of data with this technique, you have to add a special prop to every item you are rendering in that list, in this case to every list item, and that's the key prop. That is a prop React itself understands, and here I want to output goal ID, again wrapped in curly braces because this is a regular JavaScript expression. So now with that we don't get the warning and we get our course goals. So this is how we output a list of data. With that, this is looking pretty good. We're outputting our list of data. Why don't we now work on adding some functionality that allows us to add our own goals? That would be a nice next step. To output our own goals, I'll add a new component in the components folder. And to keep it manageable, I'll actually create a new subfolder for every component. This is not a must do, but I personally like doing this because then I can quickly find all my components. Of course, you now need to adjust your import here in app.js. My IDE did it automatically. In case that did not happen, make sure you adjust your goal list import to reflect that new folder I added. And then I will add a new goal component here in the components folder as well. In there, add a new goal.js file and a new goal.css file if you want to apply some styling. Now in a new goal.js file, we first of all need to import React from React. You always need to do that, otherwise you can't use JSX in that file because, keep in mind, JSX is translated to React create element. And then here I have my new goal component here. We could accept props, but as long as we don't need them, we don't have to. And then I export new goal. Now in app.js, I want to render new goal. So I will import new goal. Again, the name here is up to you, but it should start with a capital starting character. And I import this from components, new goal, new goal. And then here we can render this above our goal list, let's say, like that. Now this wouldn't work because new goal is not yet a valid React component, because it's a function right now, but it's not a function that works as a React component because it's not doing one crucial thing. It's not returning JSX. So let's return some JSX here. And there, to keep things simple, I'll add a form. And in that form, I'll add an input field, type text, self-closing element. In regular HTML, this doesn't have to be self-closing. In JSX, it does have to be self-closing. And then a button, which is of type submit, where I say add goal. A very simple form. And if we now save that, you should see it here. Now let's add some styling to make this look a bit prettier. For that, I'll add a class to the form, new dash goal, and I'll import the new goal CSS file into the new goal JavaScript file. And then here on the new goal class, which is added on the form, I'll add a margin of 2 rem in all directions and text align center so that this looks a bit nicer. And now we could also style the input and the button, but I don't want to spend too much time on that, so I will leave it the way it is. Now right now when you click the button, by the way, this page will reload because right now the default browser functionality will kick in, which is that when a button of type submit is clicked in a form, a request is sent to the server that served this page. Now that's not the behavior we want here though, because here I don't want to send a request to any server because we're not doing anything on the server side. Instead, I want to handle that click with JavaScript. And that is the first thing I'll do here. Let's see how we can handle events, because thus far we haven't done that. I want to handle the submit event of this form here. And React makes that simple. We can add event listeners to any element, not just to the form, but to any element by adding on, lowercase on, and then the name of the event. Now, not every event is supported on every element, but here you got the default HTML elements available. So for example, on a form element, you have the submit event, on submit. On a button, you also have on click, but since it's a button in a form, it's better to handle this on the form itself. Now, what do you pass as a value to onSubmit though? As a value, you have to pass a function that should be triggered when this event happens. So a pointer to a function. You could do this here with curly braces and then an anonymous inline function, but I don't like that too much. Instead, I will create a new function here. And in JavaScript, you can create functions in functions. So instead of the new goal function, which it still is in the end, I can create a new function. I will create my add goal handler. Now the naming is up to you, but I like this naming of having handler at the end of my function name if it is a function that is triggered upon some event. So this is a function. In this case, I'll again use an arrow function, which is not a must do, but I will use only arrow functions here. And onSubmit now can point at add goal handler. Don't execute it here, so don't add parentheses. Instead, you just want to point at the function so that the browser and React, in a common effort, can execute this function for you when this submit event occurs. Now, this function will get an event object, an event parameter, passed in automatically by React. And there, for example, we can call prevent default, which prevents the browser default of sending a request to some backend, which it shouldn't do here because we're not handling this on the server side here. Our server only serves that single index HTML file. It does not have any logic to handle any submissions. Instead, I want to handle it here in JavaScript on the front end in my React application. And for the moment, I'll ignore what the user entered here, and I will simply instead create a dummy goal. And I want to pass that dummy goal to app.js and add it to my course goals here so that it then is rendered here. Now, step by step. We can create a new dummy goal, of course, in that add goal handler by adding a new goal constant here, which is a JavaScript object. The ID here could be a random number with math random. This, of course, is not really a unique ID, but it's good enough, and I'll convert it to a string. It's good enough for our demo application here, I mean. And then the text here later will be the text the user entered here. For now, just some dummy text. My new goal. So now we have the new goal here. And of course, we can console log that to see that everything up to this point works. So if we save that, we see our form here. And if I click on add goal, the page will not reload, but instead we see this dummy goal here. And I can create, of course, multiple goals, but at the moment they're not added to this list. To add them to the list, we now need to get that goal out of the new goal component to the app component. Now before, we learned we can pass data around with props, but that was from app to goal list, so to a lower level component, a component which is included in app. Now it's the other direction. We want to pass data from new goal to the parent component, so to the component which includes the new goal component. How does this work? You can also pass data back, and you still do this with props. The idea just is that instead of having props that pass in data like a string or an array or an object to the lower level, to the child component, as it's also called, you pass a callback function from the parent component to the child component. So no array or anything like that, but a callback function. So here in the app component, we could define a new function, add new goal handler. The name is totally up to you. And I name it handler because it also will kind of be triggered upon an event. And here I expect to get the new goal. And then here I can reach out to course goals and, for example, push the new goal into this array. And thereafter console log course goals. Now we have this function, and now we can pass it to new goal via props. So there we could add a prop on add goal. This is now not an event listener React defines. For all the built-in HTML elements, we have built-in event listeners. Like for example, in the new goal component, on the form, we had onSubmit. On a button, we have onClick. On input, we also have onClick, for example, because you can also handle click events on inputs. You can handle those on any HTML element. Now, in the end here, I called this an event handler. But what it actually is just a prop. Technically, there is no difference between class name, where I pass in a string, and onSubmit, where I pass in a pointer to a function. So in the end, this is just a prop of the form element which React offers to you. So here in app.js, we can also pass a prop here on new goal, which holds a pointer to a function. I just name this prop like this, not because I have to. I could name it add goal or this here, but it's a convention to name props which in the end pass functions to lower level components like event handlers, because the functions you pass down to components in the end will be called by these components upon certain events. That is how it typically works, and you will see that the more React applications you build. So therefore, I follow this convention and name this on add goal and pass my add new goal handler to the new goal component. So I pass a pointer, not the execution, but just a pointer to this function to new goal on this on add goal prop. Now that means that inside of new goal, I can now accept props here. I can accept this props parameter. I always get it, even if I don't get any props. But if I don't get any props, there isn't much sense in explicitly writing it out here. But now I need a prop, which I'm getting on new goal. And that is that on add goal prop I defined here. I want to call that function I receive on that prop here inside of my add goal handler in new goal. So instead of logging the new goal, I can now call props on add goal here. On add goal, because that's the name I chose here. And on add goal passes a pointer at a function to the component. So inside of the new goal component, I know I can execute on add goal because it holds a pointer to a function. So I now execute that function it pointed to. And I can pass my new goal as an argument to on add goal, because indeed, in the function I passed to on add goal, I expect to get a new goal as an argument, as a parameter. So now if we save everything, we should see that if I click add goal, we're outputting something from app.js line 16, which is this log here, and we're outputting our new course goals array, which are our old goals and the new goal. So passing the goal from the lower level, from the child component, the new goal component, to the parent component, the app component in this case, works. And it works with props. We just use props to pass a function that is then called by the child components instead of passing data directly from parent to child. This gives us a way to communicate back from the child to the parent with help of such a function. So now we're able to communicate back, and we are actually updating our course goals array in the app component. But what you see is, despite the array being updated, and clearly the new goal is part of the array, our output here on the screen didn't change. And that leads us to a core concept of React: state. React does not re-render this JSX code and therefore the real UI all the time whenever some event is triggered anywhere in the app. So just because I click this button here does not mean that React will re-render the entire screen just to make sure it doesn't miss any data change. This is not how React works. Instead, in the end, you have to tell React when it should re-render. And you do so by using a concept called state. This course goals array here is a regular JavaScript array. Put in other words, React totally ignores it. We have to tell React that it should not ignore it, and that instead, whenever we change this array, it should update the UI, the JSX code of the component in which we changed it. So in this case, of the app component. Now to do that, we import one other thing from the React package, and that's useState, a function built into the React library, a so-called React hook, and you'll learn more about hooks in my React the Complete Guide course, of course, a function which we can execute inside of functional components and only inside of functional components. In class-based components, you also have a state management mechanism, not focus of this course here, but you could also do it there. But in functional components, you use these hook functions, as they are called, all these functions starting with use at the beginning, to manage state. So to manage data which, when changed, should lead to the UI of that component in which you manage the state to re-render. So here in the app component, I now want to call useState, and to useState, I pass this array here. This is my so-called initial state then. I can get rid of that constant for now. This tells React that this component has some state and that this is my initial state. By the way, you can also have multiple different state pieces and they're all watched independently. But here I only have one main state, and that is my array of goals. And I tell React that I have this state and that this is my initial state. Now, of course, I want to get access to that initial state, store it in some constant, so that I can use it in the rest of the component, because course goals is now missing everywhere. So useState also returns something. It returns an array of exactly 2 elements. The first element always is our latest state snapshot, so either our initial state or, once we changed it, the updated state. And the second element of that array returned by useState is a function that allows us to update that state, replace it with a new value, and tell React that it should re-render. So here I will use array destructuring by using square brackets on the left side of my equal sign here to extract these 2 elements I have in the array returned by useState. And there are always exactly 2 elements. So it does not depend on which kind of state data you pass here. useState gives you an array with exactly 2 elements. First element, your current state. So in my case, my array here. Second element, a function to update the state. Therefore, typically we name this set, and then any name of your choice. Set course goals in my case. So now I have 2 constants created with the help of useState. First constant holds my state snapshot. Second constant actually holds a function which we can call to update that state snapshot. And we will call that function here an add new goal handler. We We can call set course goals here. And now I want to update my course goals by adding a new goal. Now, a simple form of doing that is to simply then use my old course goals and call concat here. Not push, because push modifies the existing item. Instead, set course goals wants a brand new array, which will replace the old array. And concat will also add an item to an array, but it will return a new array to which this item was added. So it gives us a brand new array, doesn't touch the old one, and we then pass the brand new array to set course goals, and React will then use that brand new array to, under the hood, replace the old array in its internally managed state, and it will re-render this component once it did so, and therefore update this course goals constant with the new array in the next render cycle, which in the end means that React will execute this function here. And therefore, when it does so, it will reflect that new data in our JSX code. So here I want to concat my new goal. And if we now save this and I click add goal, you see new goals are added to the list. Because React now re-renders this screen or the parts that need to be re-rendered whenever we update our state. Now, how exactly React re-renders and so on is not the focus of this course. You can learn that in dedicated resources like the official docs or my complete guide. For now, it just suffices to know that React magically and efficiently does re-render the page or the parts of the page that need re-rendering based on the state changes we applied. State is a crucial concept in React, and therefore it's important to me that you understand how it works. Use state is how you manage state in functional components, and your state can be anything. It doesn't have to be an array. It could be some text, a number, an object, an array, a boolean, anything like that. Use state always returns an array with two elements, no matter what your state is. If your state is a number, use state still returns an array with exactly two elements. Because the first element then always is your latest state snapshot, and the second element is a function that allows you to update that state snapshot. Whenever you update the state snapshot, React will do two things. It will update the internally stored state data. So for example here, when we add our first new goal, it will replace the initial state with our brand new state, in this case with the brand new array we created with concat. And once it did update the data internally, it will call this component function again and execute the entire function, and hence also re-render this JSX code. Now under the hood, it will not re-render the entire DOM, it will just check which parts of the DOM need to be updated, but it will re-evaluate the entire component. This also means, of course, that it re-executes use state, but use state internally works such that it only initializes that state when the component is rendered for the first time, and for subsequent re-render cycles, it just pulls out the latest state snapshot and basically ignores the initial value we set up here. This is how state works. Now, it is also important to understand that this way of updating our state in this scenario is not the best possible way. So I'll duplicate it and comment it out so that we still have it for reference, but we also see the better approach. This approach clearly works, and in most cases it will work. But you have to be aware that this whole state updating, re-rendering part of React is in the end managed by React. And when you set a new state, it doesn't pause everything and immediately re-render your app. Instead, it schedules the state update. And if you have an application with a lot of ongoing state updates and a lot of work being performed, which is not the case in this application, but can be the case in other applications, then your state update might be deferred by a few milliseconds. That means that actually maybe if a user clicks add goal multiple times, the course goals which are currently rendered on the screen might not be our latest state, because not all state updates might have been processed yet. Therefore, there is a better form of updating this. Instead of passing our new state data to set course goals, you can pass a function to set course goals. A function which receives the latest state, pref course goals, and has to return a new state snapshot. And React will then schedule all these function calls and guarantee you that they are executed in the right order, so that even if a state update was deferred, by the time the update thereafter executes, it guarantees you the first one executed as well. And then here you would simply therefore return pref course goals, which still is an array, concat new goal. It will yield the same result as before in this app, and in this simple app, this approach would have been fine. There is basically no chance of React deferring updates so long that we would end up with an incorrect state. But this is the bulletproof approach, which will always work. You only need it if your state update depends on the previous state's data, as this one does. If your state update is a new data piece which doesn't depend on the previous state, you can always safely use this non-functional form. And here, side note, we can of course also shorten this, take advantage of arrow function syntax, and get rid of the return statement and the curly braces, since we have only one expression which we immediately return. So now with that it works as before, but this is a bit of a safer approach and the recommended approach if your state update depends on the previous state. State is a crucial concept in React, and with our knowledge about state, we can now also make sure that we don't just create a dummy goal, but we actually reflect the real user input. So for that, let's go back to new goal. What we want to do is we want to store the user input in some variable on every keystroke so that we have the latest value entered by the user, and then pass that entered value to props on add goal, or to our new goal here, instead of that hard-coded dummy text we have at the moment. So here in new goal, I want to capture the user input here and send this instead of my hard-coded text here as part of the new goal. So we could create a variable here, user input or entered text maybe, which is an empty string initially. And here on input, there actually is an onChange event we can listen to, which is fired on every keystroke. So now we can add a function, text change handler. There we will get an event object, and that event object will hold the user input on event target, which refers to the input element dot value, and therefore we could set enter text equal to that. Now enter text will change with every keystroke once we bind onChange to text change handler, like this. Now here in new goal, we can use enter text, so what the user entered here, and then thereafter let's also console log the new goal here so that we can see that this works. If we now save this and I enter test here and I click add goal, we see this works and this is output here. This approach is generally fine, but it can have one tiny flaw. What if we want to reset this after adding a new goal? Of course, we can go to our add goal handler, and once we created the new goal, we can of course set enter text back to an empty string. But of course this won't do anything. If I enter this goal, you see this is not reflected here. Why is it not reflected? Because the new goal component didn't re-render. This is not state we're managing, this is a regular variable. So of course we can change it, of course we can use the changed value, but if we then set a new value to it, this is not reflected on our input because this input only has a connection to the text change handler. It does not know that it should reflect the current value stored in entered text. Now we could tell the input component that it should do so by binding its value prop. We can bind this to entered text, and with that we tell the input component, hey, the value displayed in the input should be the value stored in entered text. If we do that, we'll notice something new. Now we can't type there anymore. If I type here, the input is not reflected. Now if you think about it, that makes sense. What you're telling React is that input should be rendered such that the value is the entered text. With every keystroke, we change entered text, but entered text is not state, it's a regular variable. So that means that we change the variable with every keystroke, but React doesn't re-render the input component. It doesn't reflect the updated value. To React, the value always is an empty string because that was the last time it rendered this component and therefore this JSX code and therefore this input. So we need to tell React that this is some state and that when it changes, it should re-render our JSX code. So again, we can import use state here and convert entered text. use array destructuring here. And use state is an empty string initially, or has an empty string initially here, because I'm managing my entered text. And the second element is a function to update the state, which I'll therefore call set entered text. And now here on every keystroke, I set my entered text to the value in event target value. And here we don't need that function form of updating the state because we have a brand new value that doesn't depend on the previous state. So we can just update the state like this. And now this will re-render this component whenever we call set entered text, so on every keystroke, which sounds horrible, but which is great. React will do this in a very efficient way. And therefore, this latest value will be reflected on the input element. And here in add_goal handler, if we want to update enter text and reset it, we can therefore call set enter text and set it back to an empty string. And with that, we now have the best of both worlds. We can enter something here, that all works, but we also can manipulate it and reset after adding a new goal, like this. So this is now another use case for state management. And of course, there are many use cases in a React application. And here we are using state management to create something which is also sometimes called two-way binding. We're binding the value of the input, and on every keystroke, we're updating the value which we then bind back to the input, so that we always reflect the latest value inside of the input, but we also are able to manage this in a state-driven way, so that we also have a chance of manipulating the value from inside our code up here and reflect this back into the input in this case. With that, we have another scenario of state management, and we are now able to add our own goals. This is React in a nutshell. Now there is way more to React, and we'll see way more throughout our course project, where we will build an entire app with React, where we will also add routing and do more complex user input management and so on. But for this refresher, we learned everything we need. Now, as I mentioned multiple times, really also take some dedicated React resources, no matter if that's my complete guide course or the official docs or any other tutorial, if you are serious about React. This course has not the goal of teaching you React from the ground up. I do explain a lot to ensure that we're all on the same page, and I will explain every feature we add throughout this course, but in dedicated resources, you simply get a way deeper and better insight into React, into all its features, including features which we don't need in this course, and how it works under the hood. So that's my strong recommendation. From this refresher, the most important takeaway is that you understand that React is all about components, that components are functions that return JSX or JavaScript classes with a render method, which we don't use here though, that components can receive props to receive data from parent components, that props can also receive functions, pointers at functions, so that the child component, the component used in another component, can communicate back to its parent component, so to the component using it, and that you have this very important concept of state, which allows you to manage data that, when changed with one of the state updating functions, actually causes React to re-render the component and re-render the JSX code and re-evaluate what needs to be output on the screen. This is what allows you to render dynamic content with the help of React. These are all the important takeaways. And again, there is more we will learn and more you can learn about React in general, but these are the concepts which definitely should be clear by now. I did update this course entirely. I completely re-recorded this entire course, and in this video, I'll clarify what this means for you, what changed, and how you should proceed with this course if you just bought it, if you already completed it, or if you're in the middle of the course. As a side note, you also find this document attached so that you can also read everything instead of watching this video. Now let's start with the reasons for the update. Why did I update the course? The reason is primarily that React Navigation, one package which we use in this course, changed a bit, and therefore a lot of content in this course was outdated and a bit hard to follow. Now, the rest was fairly stable, but there have been some smaller changes here and there. And of course, I also received lots of feedback, which I also wanted to incorporate into this course, because frankly, I can make the course better than it was a couple of years ago. So for those reasons, I did sit down and re-record the entire course. I also polished a lot of the example apps that we built, and I added some brand new example apps so that if you go through that update, you will build more apps than before and more exciting apps, as I believe. Now, I will say that the section structure is the same as before. We have the same sections, so the general order is the same. However, all the lectures in the sections have been replaced, and it's not a one-to-one replacement, so the number of lectures per each section changed, and it's not like I just swapped the lecture videos. That's not the case, but the general course structure is as before. We start with the basics, then dive into debugging, then learn more about key features you need to build real apps, and so on. But everything was re-recorded, all the lectures were swapped, and as mentioned, all the apps are new or polished, so it is a brand new course in the end. Now, this new course, which I therefore created, was inserted into this existing course in front of the old course, because on Udemy there is no great way of providing an update for free otherwise. Therefore, I did insert this new course into the existing course, and at the moment there therefore are two courses in this one course. Now, this will change on April 29th, because on that day I will remove the old course, because Udemy doesn't like it if you have bloated courses, and of course a lot of students also don't like it, because, for example, if you want to get your certificate of completion, you need to finish all lectures, which at the moment means the new and the old course, though you can manually tick those lectures as completed, so you don't actually have to watch the videos. Nonetheless, having two courses in one course is annoying, so the old course will be removed on April 29th. The new course, of course, will stay here. I will also make the old course available after April 29th, because on that day I will add a new lecture that contains download links to all the old videos, so that you still can watch those even after that date. They're just not in this Udemy course anymore as lectures, but you can still download and watch the videos after April 29th. So you essentially got a brand new course for free with this update, and I hope you like that, of course. But of course, this also brings up one important question. How should you proceed? And that, of course, depends on your current state. If you haven't started the course yet or just barely started it, so if you're at the very beginning of the course, maybe just in the second course section, for example, or if you're well into the course and you're a couple of hours into the course, or if you maybe even completed the course already, if you watched the course in the past and you're done with it. Well, if you just started the course, or you're just in the second section of this course, my recommendation is that you restart the course. Maybe go through the first lectures at double speed, because you already know all these things, but definitely restart if you have the time for that. If you don't have the time for that, if you don't want to restart, you can also simply proceed, because, as I mentioned, the section structure stayed the same. You just need to restart the section in which you currently are. But otherwise, you can proceed unless you're already in the navigation section or thereafter, because, as mentioned before, that was the main package that changed and triggered this course update. Therefore, we have significant changes there, and if you're in that navigation section or thereafter, you should definitely restart at the new navigation section. That's therefore also my recommendation if you're already well into the course. There you should go back to the navigation section, where you learn how to add navigation to a React Native app, because you will now learn it with the latest version of that package, which is different, which requires different code, and the update of course covers those differences and covers the latest version of the package, and therefore definitely go back to that section, and then you can continue from that section on with the rest of this course. Alternatively, you could of course also restart the entire course if you want to. Or if you absolutely don't want to restart and you don't want to go back to the new navigation section, then you can, of course, also complete the old course and just consider going through the new course at some point in the future. But my recommendation is that you do go back to the new navigation section and restart at that section. If you did complete the course in the past already, then you can ignore the update, but of course you can also consider going through the new course again to see those new apps, to practice with those new apps, to pick up some new pieces of knowledge here and there. But as mentioned, you can also ignore the update. You don't need to go through the course again. Because, and that's really important to me, React Native itself didn't change. What you learned with the old course is still correct. And if there wouldn't have been this big change to the React navigation package, there wouldn't have been a strong reason to completely re-record the course. So what you learned is still valid, but of course the new course still is a bit better, has more example apps, more polished apps, so definitely a better course. But nonetheless, what you learned is valid, and you did learn all these key features about React Native in the past as well. So that's the update. That's the information video for this update. If you got more questions, of course, post them in the Q&A section and I'll try my best to answer them there. I hope you liked the update. It, of course, was a lot of work, but I'm happy to provide it for free. So I hope you enjoy it and you get a lot out of it.